Well, good day, everybody, and welcome back to the Camera Life podcast. It is, Thursday, the 23rd of April here in mostly sunny Victoria. And today we've got a super special show for you, a really interesting piece, because, of course, we are joined by Wayne Rogers from Imaging by Design. G'day, Wayne. How you doing?
Greg, very well. Justin, how are you? And to the audience
great.
too. Hello.
Yes, hello, audience.
Hello, indeed. Great to have you on the show. We're going to unpack everything about imaging design that we can fit in the time slot we've got. Reading through the services on your website, blown away by some of the stuff that you do. Everything from, Leica camera repairs, which we were just discussing before we went live, through to spectrum conversions, professional services. You even do design of imaging solutions, which is phenomenal.
Yeah.
So welcome to the show. Great to have you on board. Just before we went live, we got into a question. We got into a discussion about, how different camera brands handle repairs and warranties, and which ones prove to be the more robust out there. So, in your experience, is there a brand that stands apart from the rest in terms of build quality, repairability, maybe?
Oh, you like to go in deep with that first question. So, Greg, I'll try and wrap this up into a put in perspective. Is that
Sure.
Our business, Imaging by Design, is sort of more or less the creation from Camera Clinic, and a lot of people remember Camera Clinic from the decades that it has been. And before that, it used to be Photographic Clinic, and that's about 50 years ago when my father started the business. So we've been doing camera service and maintenance for decades now since then. And we've had a long-term standing with all the suppliers and manufacturers. Because we've had such a long experience and history with cameras, we understand the integrity, the algorithms, and we understand the mechanics of cameras really well. For that reason, we have got a good reputation and of being straight up honest. And we don't sell cameras, so we don't have a lot to gain by recommending one over the other. So to your question, Greg, is that you think about this, is that Kodak and Fuji invented color, and they're masters of it, and they do it really well. Fuji cameras render color very well. Now, we've had this proven many times when we do service work for school photo companies, and they're thousands, hundreds of thousands of images every year. They want to render skin tones and colors perfectly without having to do much work in post-production. So their choice camera was the Fuji S1, S2 when they first came out, because they just rendered color really well. Then you've got Nikon, Sony, Canon. We'll get to Leica a little bit because that's a slightly different kettle, although they're all black. So with Sony, Canon, and Nikon, they have what we call a cast. They have a particular look about them. Sony sit closer to what you would see out of a phone, an iPhone. It's quite a dynamic image. They all have the options of flattening that image and having not a raw, but certainly an untainted or tinted image out of the camera. And that's that flat mode. You don't get it as standard. By default, they're set to something that actually is a little bit more enhanced. So getting back to your question, which one is the best build quality and image quality? People get hung up on pixels and heaps of them. We don't want more pixels. We just want better pixels. The camera that yields the better image is the camera that has the best lens on it, because it's the optics that are more important than the actual sensor itself. The sensor has to be good enough to render what the optics can produce, and the optics currently are exceeding what the cameras can do, particularly in the new mirrorless series. They're very sharp. Do you need sharp? Do you need color rendition? There's another 2 or 3 podcasts just in that question alone.
Well, we can book you in a calendar here. So.
There's some ripper cameras out there, some really lovely and beautiful builds. There is a formula that, yes, you do pay a lot for a good quality lens, but that's worth it, and it's an investment, definitely, because that lens is going to stay with you for life. The camera body you can upgrade and change as you get circumstances that might require higher resolution, be it product work, maybe definition of landscape, maybe even Astro work. Or there might be a camera that you need to get low light, a high ISO, low noise sensitivity, and the resolution is not that important. But at the end of the day, it's about the color rendition, and it's about sharing those images. It's, memories are meant to be shared, and it's what you do with them. And people get caught up in the technicalities of cameras a lot. We have clients that are reaching out for us to repair the old CMOS, the old TTL sensors, because they render a really nice image. These things are only 3 megapixels to 8. That's it. They're compact cameras that were long gone 15 years ago. So again, it's a beautiful thing because it's personal, and we are sharing experiences. And to coin my own phrase, that camera is probably the single most complicated piece of equipment that anybody will ever own. It has electronics, mechanics, and optics all on the highest level. It sits dormant for most of its life until you pick it up to capture a moment in time that never repeats. So, it's a really highly sophisticated piece of equipment.
Yeah.
And these are capturing memories. These are capturing time that you will never, ever see again if you can't stop that moment. Yeah. It's how you record it, you do with it.
Absolutely. I think it's a wonderful outlook. More recently, I've been sort of saying, no, it is a bit, but it's also realistic. I often say, and I'm a romantic as well, I often say that, we do what we do with photography to capture what is before it becomes what was, because you're right, everything is fleeting. And there's so much that we've learnt about, maybe the last 100 years purely from photography, from old photography. We've learnt so much about the world and people and existence. And I think that needs to continue, which is why we need to bring the challenge to AI, to keep creating real images, amazing answer. Thank you. Before we roll back the clock, really keen to hear about your early experiences with the business and with your father working with the business. But before we do that, Justin, do you want to say good morning to some people?
I do. Yeah, I've been watching the chat, just keeping an eye. Everyone's rolling in. My mouse isn't working. There we go. Paul was here first. Good morning, Paul. Philip Johnson, good morning. Thanks for the happy birthday message, Philip. That was very nice of you. Robert Varner, good morning. David Leparati is here, infrared photographer extraordinaire. He's been constantly sending us in things to learn from about infrared photography, which has been very fun. Stoke the fires of my my purchase decision. Jeff, good morning. Lisa Leach, David Mascaro, Philip Thompson's here. The plumber, Matt, good to see you. Bruce Moyle, Lucinda. And David Leparati finished off by saying, well said. It was well said. I just think it's so cool that someone who is entrenched in the technical side of camera repairs, camera conversion, customization, summarized so beautifully that it's actually more important what you're doing with the images rather than any of that technical stuff. How you're sharing them, what you're doing with them, trumps anything about the sensor technology or whatever, even the optics.
Yeah. We've got photographers that are creative with pinhole cameras, so they can do anything with it. Just a question then: birthday? Whose birthday?
Oh, it was my birthday yesterday.
Okay,
and I spent it working most of the day. I didn't finish. I was on a shoot until I was on top of the grain silos in Gornong, which is just north of Bendigo. On a 23-meter grain silo. Photographing guys setting up high ropes rescue stuff. So that was my birthday.
Oh, that sounds amazing.
Yeah. It's probably better than a bottle of wine in a restaurant.
Well, I could take either at that point. It was starting to get chilly. There was a few delays standing up there, fully harnessed up, just with a helmet on and a little torch, just waiting. It was, but the photos. Hopefully, the photos will be worth it. It was very cool.
But it's a pretty cool way to spend your birthday, regardless. Like you did something pretty unusual, Yeah,
exactly.
Yeah,
and back to it, you get to share it with everybody.
Yeah,
exactly.
That's a beauty, and anybody can have a camera and do that. They do. in their phone. And to the point of that is that I've often been asked, has the humble camera in the phone interrupted the sales and the use of digital cameras? And it has, but it has done it in a positive way. People are still capturing and sharing memories, and they're doing it more freely than they ever have. And they're being able to be creative in a manner which is non-technical. So you can use an app easily on a phone to become creative and do things that would take you years of practice and understanding some clunky bit of software or technique to do that without post-production. With AI generated enhancements, you can do what's amazing things. It's still your image and it's still creativity. There is a level of artificialness about it. There's no doubt about that. And AI, I like to think it is artificial copying, because it is a lot of that. And we see that in the website, and they see that with technical information. So it doesn't distract from, what a digital full resolution, high dynamic range digital can do. So those cameras certainly yield a better image and a more dynamic image than what a phone will. However, horses for courses, each one has its own place.
Yeah.
And I think
you still see...
Sorry, Jay, you go.
I was just going to say, you see photographers, including me and Greg and everybody, using their phones sometimes because it's just more convenient. Sometimes even when you've got your camera gear with you, you might still use your phone to take a photo of something that you're just like, I just want to get a photo of that to send to a friend to show them that we were at this restaurant or something. A photo of the menu. You know you're not going to make art with it, but it's just faster video. Click, send, share, done.
It's highlighted vanity as well. There's no doubt about that.
When we were talking to Adam Edwards a few weeks back now for his interview, he said that often he'll pull out his iPhone. He's a landscape photographer and runs workshops, but sometimes he'll use his iPhone just to find composition sometimes. While he's sort of scouting an area, he might go, oh, that's a good spot. I might take one from here, and I might take, and then he goes back to his camera gear and sets up and does the full experience. And I think, like you said earlier, it's just another tool in the toolbox that we have to create images and make art or share or make a statement, whatever it may be.
Yes, you're right, Greg. Scouting with phone cameras is great because you've got your GPS and you've got a compass, so you know exactly what you're looking at and where.
You can pin locations.
I think it was Brett Wood as well that said that was the first thing he does at any location. I'm pretty sure it was Brett Wood, Greg, when we were talking about his New Zealand trips and stuff. Is like the first thing he does when he gets to a beautiful spot, he doesn't get his camera out. He'll just wander around, and if he wants to, he'll use his phone to sort of frame up ideas before he even takes his camera out of the bag. So
that's pretty cool.
Very cool.
Now, Wayne, let's roll back the clock, perhaps even to before your time, but after the dinosaurs. You said that your father started this business. Is that he started it? It was his baby?
Yeah, absolutely. So my father, Laurie Rogers, he did an apprenticeship with Wagner's here in Melbourne, and Wagner's they sold cameras, but they also sold everything from all different pieces of equipment as well. But his main interest was in photography. My grandfather is also a mad inventor and a nutter of electronics, and I think that's probably the inspiration where we've all got it come from. He was one of the original founders of Retrovision, so he's been around for my grandfather. And he actually. He during the war, he designed an X-ray machine that was used in Darwin for on some of the troops then. So he's quite well known in that area. My father, Laurie, he boldly went out on his own after spending some time with Hanamex as well and running the service department. They did everything from cameras, golf clubs to outboard motors there. So it's quite a broad range of experience. His time at Wagner's were with a lot of the German technicians, where you had to learn German to be able to be in the room and learn cameras. So he knows a bit of German there, which has been helpful because I've spent a lot of years in Germany with Leica since then doing training. He started Photographic Clinic sort of 50 years ago, and then evolved to Camera Clinic. After that, a name change. I came into the business 35 years ago, and we took what was Photographic Clinic then to Camera Clinic into the 21st century with digital. So I introduced that with my background in electronics and photography. So I've done a photographic course as well at Photo Studies College, which was a lot of fun with Roger there, and he was quite a dynamic teacher. So yeah, dark room, set it up in my mate's laundry in Ivanhoe, and we did all our black and white stuff there. It was good fun. So yeah, I know it through and through. I love imaging, and I also used to run a company called Sound Lighting, which gave a bespoke experience for parties. We would just take DJ equipment, but we'd also do ambient lighting as well. So we'd be hired for 21st birthdays and things like that. So that was my original entry into lighting. And ever since then, I've done a lot of special design lighting pieces of equipment in UV, for dermatologists, etc. Visible, invisible, forensic, all sorts of stuff. Back still, and this podcast may go on a little bit longer because there's heaps of information. Greg, on your original question, the history, we went to Camera Clinic. In the 80s, we were the first companies to get involved in digital cameras with Rudolf Gunz, who sold Olympus, and they were the first Olympus digital cameras that came into Australia, or virtually into the world. Kodak had some before that as well, but Olympus did it in the mass market. Yeah. So that really gave us a good introduction. Then in 2000, we took on Kodak as a service contract. It was just before that, actually. And I remember my dad was away. I rang him up. I said, guess what? We've got the Kodak contract. And he goes, oh, Struth, we'll sort it out when I get back. And he got back, and I had a look, and he goes, oh, my God, what have you done? Because it was like we were doing 2,000 cameras a month at that time, and we had 28 staff. So, wow. Yeah. There was a lot. There was 19 technicians cranking through camera repairs. So there was a lot of volume. There was huge volume there, and that was when digital became huge. It was mass market. Yeah, and it was taken up by everyone. Before that, there was plenty of analog cameras, lots of quality stuff, lots of Blads, lots of Leicas, and we said about Kodak, and then I'm going to turn my phone down in case it rings. We talked about Kodak and Fuji being the inventors of color. Leica, Hasselblad, and quite a few other cameras were synonymous with quality builds. And the reason for that is they're metallurgy. They understand metals, and they use steel that has a higher carbon content, so it's stronger. They use particular brasses, aluminiums, alloys, and everything's very well built, so much so that you can take the cameras apart 3, 4, 5 times. So in a 15-year lifespan of a professional photographer, you've had the thing serviced 4 times with a full strip down, because you've done tens of thousands, hundreds of thousands of shots. You can do that with these cameras because they're built that way. Whereas your cheaper cameras, you get 2, 3 times, and then you start to get failures. The screws strip out, things like that. So that's the difference. It's the materials that they use is the biggest difference. Yeah. So manufacturing techniques have changed a lot. We know that. We manufacture as well ourselves, so I understand what's involved in that part of it. And
so what do you manufacture? What sort of components are you making?
Okay. So to bring us forward to today, Imaging by Design is an offshoot from Camera Clinic, and always has been operating in the background. That's the company that I started and are responsible for, that do all the conversions. So always has been working there side by side with Camera Clinic. But we now do we have been doing infrared conversions and design and modifications. So for example, what do we manufacture? Don't hold this against me, but last year we built 400 speed cameras. Now,
okay, yep.
That's okay. I don't speed.
They do go over speed. Yeah, sweet. So they go overseas. So these ones are sold internationally. Now we build mining rigs for 3D imaging, underground photogrammetry.
Yeah.
Difficult to use lasers underground, so I have stereo. Might be able to share a screen with some of these things because our website is rubbish at the moment. We're in the middle of upgrading it, so there's not a lot of information on that. So we've built everything from thermal cameras for road surface mapping. We've put 5 high-resolution cameras in a helicopter, used the LiDAR to track the power lines and focus on these lines at 70 kilometers an hour, take sort of about 1.5 gig of data per minute of these lines, looking for 1 millimeter bulges in the power lines. And these big high voltage transmission towers.
Mm-hmm.
So that was quite an interesting project. We've built just recently a fence line camera, which is used to align fences for rural properties. You put a camera at one end, you take the tablet, you look at yourself holding a fence post. Oh yeah, that's straight. Slam it in the ground, and then you do the next one, and the next one, and the next one, so you get a nice straight fence line. Simple concept. But it was quite a challenge to get that sort of thing happen. So we do manufacture everything from cables to illumination, special lighting, a lot of UV stuff, and custom built circuit boards. And we also have a software department where we've got some software engineers that write software for driving cameras, for interface, interactive AI supports, large servers that sit behind firewalls for Transport New South Wales, for example. They just took up one of those recently, one of our image road systems. Two cameras sit on top of a vehicle, taking shots of road surfaces, looking for cracks, and then we throw a lot of AI at it. We do a lot of manufacturing.
That's amazing. That's so fascinating that you're creating bespoke solutions from the ground up.
It's crazy.
That's impressive.
How big would you say is that part of your business of imaging by design? How big is that compared to the more, things like spectral conversions and stuff like that? Are these projects the main thing, or the repair side of things, or are these projects kind of like they come and they go and they're complex while they're happening, and then there might be nothing for a while, and then there's another big one that pops up?
Yeah, Justin, you're correct about that. It's difficult to predict, and we try to have as many projects in the pipeline as possible, and then we will schedule a team to work on that project, and that might go for 6 months or 2 or 3 years. There's one coming up at the moment we're tendering for, which would probably be a 3-year project for full 3D mapping of human bodies, looking for skin anomalies, mole map, basically, that sort of thing.
Wow. Yeah.
So, and it's got to be mobile, and that's the key. It's making it mobile because we want to get this to regional areas where you've got workers outdoors, mining, building, construction, sports persons, footy players, etc. Even just truck drivers that are exposed to UV, but that don't readily or aren't checking themselves. I had a close friend that passed away from melanoma that was taken out 14 years ago, and not all of it was removed at the time. And just sadly, this happens too often where it's preventable. So we're having an opportunity to build something that's going to change that, make it available for everybody. The dermatologists are hard to get, and
expensive.
Expensive, yeah, exactly. So if we can get imaging done in a regional location that everybody has access to a dermatologist, then doesn't matter where you are, because those images can be reviewed. Yeah, absolutely. So the projects come and go, and you've got to maintain that. They're huge. I mean, these are big projects. This tenders $8 million, so that gives you an idea of what the size of the projects are. Having said that, the day-to-day camera repairs are what keep bums on seats. There's a great bunch of technicians here that are really passionate. They're all photographers. They love and breathe it. It's like a nerd city for photographers up there. And it's a great team. We're really happy with everybody there. And then there's our engineers and developers and things like that. So we pull in resources when we need to. We've got a small manufacturing here, which we do prototyping, CNC machines, printers, UV, resin, all that sort of stuff. And so we can do the proof of concept units. We can do the first demo prototypes, and then if we need to, then we'll get the manufacturers, and we'll try and do everything in Australia. And that's the key to our philosophy, is that keep it local, Australian.
Yep.
Yeah.
That's huge. That's absolutely huge. And so, how big is your core team?
Okay, so we
said that you can scale up and down for projects, but the core team, bums on seats. How big's the team?
Yeah, so at the moment we've got 6 camera technicians here, and they're just cranking through photographic camera repairs every day. So be it all different brands, makes and models. We specialise in high-end digital stuff, but we also optics as well. So that's one of our big core repair processes is our optics, and especially when it comes to focus optimization, where you've got a combination of different lenses and bodies, and you just haven't nailed that focus. You'll get it every so often. You get that really razor sharp shot, and you go, that's it, that's the one I want, but it's not consistent. Now with digital photography, you should get at least 8 out of 10 shots spot on sharp with today's current autofocus system.
Yeah.
Okay. The ones that you don't is because of limitations possibly in the autofocus system. Mirrorless behaves differently to a DSLR, because the DSLR has a dedicated autofocus sensor in it, whereas mirrorless cameras are using the sensor to do the focusing with a thing called phase shift. So it gets quite tricky, but they're simply not as good in low light, low contrast subjects, mirrorless cameras, to focus. That's why the Astro photographer will be manually focusing. It's as simple as that. You zoom in on the screen and manual focus.
It's interesting you say that, Wayne. Jim, who comes on this podcast a bit, he was my business partner. We shot weddings together for 10 years. And when he noticed, particularly when he went to the Z8s, the Nikon Z8s we were using D850s for years, which are just a bulletproof DSLR for stuff like that. He had particular trouble shooting dance floors with the mirrorless, even though he was often using flash and stuff like that, but just acquiring that focus, it never was any trouble at all with the D850. And then the Z8, he was missing shots, and that change in system going to the on sensor autofocus was just a huge, because obviously dance floors are pretty dark usually, but like this is like 11 p.m. at a wedding kind of dance floor stuff. DJ lighting only. And it was just something he hadn't considered, because everything else is such a leap forward. Autofocus tracking at 1.2 and it just nails it every time and all that stuff. And then you get to that end of the night and you're like, it does have drawbacks.
Yeah, you're right. I agree. He would have experienced what we see a lot of, where the say the CMOS sensor, the spectral response of that sensor is limited compared to an autofocus sensor. It's as simple as that. Doesn't have it has small pixels. It doesn't have the contrast differential. However, you've got, like you said, you've got those great features where you can focus track objects. That's AI. That's intelligent filtering and object detection. But to focus on a subject that's forward or backwards, it has to use a contrast and some sort of a beam split. And the dedicated autofocus sensor goes outside of your visible spectrum to do that as well. So it's very sensitive, low light. It's like these pixels are huge that are in an autofocus sensor. Would be probably 20 times bigger than your standard CMOS sensor pixels, easily. and
Wow.
they're just made to pick up low light contrast. They're sensitive to red and deep red as well. That's why your autofocus sensors on your flash are red. You know, the beam that comes out. Now they don't work on a digital camera because it's not sensitive to that frequency. They have to be green, and no manufacturer at the moment makes a green autofocus assist flash hot shoe unit. So you're buggered in those situations. There's a lot of red. There's a lot of red and a lot of artificial lighting, and it's a real tricky one.
I feel like we need to translate that for our US listeners. You're buggered means you're going to have trouble. You're going to have trouble in that situation. Wow. Okay. I knew that tech, but that's the clearest it's been explained to me. Why that limitation is so great. Why the change is so great. I didn't realize that the sensitivity, not only that those pixels were so much bigger, but also it was going beyond the visible spectrum a little bit, and using, I guess, more data more light to potentially grab focus on something. Wow.
Yeah, that's impressive.
Very cool. You know what I forgot to do, Greg?
What did you forget to do?
The sponsor thing for us.
Oh, the sponsor read.
This podcast. Yeah, because it's a professional podcast. We need to do our sponsor thing.
If we don't do it, we're buggered.
If you need a leather camera strap, one that's made here in Bendigo, Australia, go to www.luckystraps.com and you'll find our full range of quick release handmade leather camera straps that fit all of these great cameras that we're talking about. They don't fit the speed cameras that Wayne makes, or that rig that he put on a helicopter, but they do fit all the other stuff, Nikon, Leica. So go and check it out, www.luckystraps.com. You can use code Greg for a nice discount, or use code Justin because it was my birthday, whichever one you want. It doesn't matter.
Now, unprompted, and I've got nothing to gain from this, but we see those straps come in on some clients' cameras.
No.
I do. And I love them. They're great because they're really solid. Yeah, we see them.
Do you want, if you or anyone from the team wants one, just yell out. We'll send it. We could do you guys a nice imaging by design logo for it.
Yeah, sweet.
Like.
Yeah.
Do it. And have a few
laser
kicking
etching on it. Yep.
Yeah, we don't do laser. We get a plate made and we press it in into the leather. Laser can end up a bit rough. This is just pressed in, or you can put like a foil on it or something like that. We did it. You might have spotted some of the Canon ones for the R5 and the R5 Mark II. We worked with Canon. Oh, do you guys see many Canons? Because that's the CPS. Yeah, but you still do Canon as well. Or
absolutely.
do you do the CPS stuff, or is
no? We do on the spot sensor cleans, and we do hundreds of them. We're doing lots and lots of people, so people can drop in at any time without a booking and just grab a sensor clean. So you can do a paid sensor clean, or you can do. At the moment, Canon have only got CPS sensor cleans done at Sun Studio in Melbourne and themselves in Sydney. So we'll have a word to them about that. But you can come in with your Nikons, Leica, Sonys, and things like that, and get them done. Yeah, and your Nikon NPS, not a problem. So there's no charge. Okay. Yeah, and that's a while you wait service. Takes about 45 minutes. You allow that, but you don't need to make a booking. So the paid sensor clean for any size sensors only $66.
Yeah, that's amazing.
Oh, that's good. Yeah, that's good. And these mirrorless sensors, they get dirty so much easier.
So easily.
I have so much trouble shooting. I'm way more. I used to be just all over the place when I was shooting weddings with DSLRs. I'd leave lenses off and it never seemed to give me too much trouble. But switching to mirrorless now, have to be so careful switching lenses out and about in the dust and stuff like that. I make sure the shutter thing, because it closes the shutter. So power the camera off to change lenses now, so that the shutter closes. But are there any other tips?
Oh yeah, I was hoping you'd say that. There's heaps. So with sensors, dust on sensors, it's a huge issue. It's massive, and it's unfortunate that manufacturers are making cameras that are forcing clients to have to clean either their own sensor or take it in to get cleaned when it does get dusty. It's it's a conundrum that they've been grappling with for years. So the closer the front of the bandpass filter, and here's an example of a sensor here. I just grab this out of our box of props. So here's our sensor here. I'll try and get that in the light there.
Yep.
The bandpass filter on the front. And by the way, you say mirrorless cameras, we often see them come in with fingerprints. Be so close to the bayonet mount that people have slipped while handling it, fumble, bang, fingerprint on it. Yep. Yeah, and they absolutely freak out. So in most cases, there's no issues to cleaning that. On the bandpass filter, which is this glass here at the front, and by the way, that's the one that we remove when we're doing a sensor conversion, you get particles of dust. Now, anything of 3 microns and above will show up on the sensor, definitely. We can't see those with our eyes, but it shows up. And it only shows up in small apertures. So when you stop down f5.6, you won't see it, but f8, you'll start to see it. f22, they're like dogs. They're there. Yeah. So, yeah, I'm reining it in. I'm being careful, boys.
No,
so,
just be you.
So, and they stand out because at f22, it's the difference between standing underneath a single light bulb or standing underneath a fluorescent tube. You can imagine the shadow that a fluoro casts. Very soft. You look, you can see it sort of here. I've got some direct light there and a bit of a lot of shine there. How come I need a matte finish on the front there. So anyway, have we? Okay, we're still live. We just
yeah. Just glitched for a second. We're all good.
Glitch. Yep, that's fine. So what I'm saying is that at f22, the light that comes through your lens is very sharp and directional, and the dust that sits in front of the sensor casts the shadow, and you're actually photographing the shadow of the dust. That's what you're doing. When you're shooting at f5.6 or if you're fortunate enough to have a 1.2 lens, nice prime, then you won't see that dust because it doesn't create a sharp shadow. It's as simple as that. Mirrorless cameras, the sensor's closer to the bayonet mount. They haven't got a mirror to stop the dust falling on it. They don't, and the shutter is often open when you take the lens off. Now lenses are like bike pumps. Some of them, you get a 200 to 500 mil lens, and you pump that, and you'll feel the air on your face as you push it, zoom in and out. Now, in that current of air are particles of dust. Depends on the atmosphere you're shooting in. You could be in the center of NT in a dust storm, and you forget it. You're just going to be caked in it. So that the dust on the lens, closeness to the bayonet mount are all contributing factors. If you're doing a sensor, lens change, you try and do it this way and put it on facing down when you mirrorless cameras, or you do like you said, Justin, as you turn it off and the shutter will close. Not all mirrorless cameras do that, but when you can, you want to do that. It's definitely helpful. Keep the back of your lens clean. Keep the outside of your lens clean because it's going to suck dust into the camera. A mirror, a DSLR that's got a mirror has got one more step in between, and the shutter's always closed, and that mirror is also a deflection from the air. It ends up going on your focusing screen, and you see it. So if you see dust in a DSLR, when you look through the viewfinder, you're not going to photograph it because it's on the screen. It's not on the actual sensor. So don't freak out about it. Cleaning and keeping them clean is the next challenge.
So funny story. I've been shooting this rescue stuff I was talking about where it's up on the silos. I was shooting that the day before at like a fire tower. And I got home. So my R5 Mark II had a ton of dust on it, and I sent it in to get it cleaned, I think at Sun Studios finally, because I shoot hybrid photo and video as well. So it's like video, you can't do anything about it. And then you're moving around, you just see this blob just floating around the sky, like, Anyway, perfectly clean, beautiful sensor. I was like, yes. And then I got back and I downloaded the images from this shoot at the fire tower, and I see this big kind of smudge in the sky in one of the shots, and I went, oh no, what is that? Is that, maybe that's on the lens or something? Go to the next shot, exactly the same spot, and I'm like, oh gosh. And then I look at my settings, and it's at f4, and I'm like, what is there, a bird stuck in my camera or something? Like at f4 it's showing up, and then I flick a few, because I knew I did an f16 to get a Sunstar a few forward, flicked a few forward, and it's this like massive, like on my screen. I opened the camera up, and it was like almost like a tiny little hair or something. It was huge. I wanted to ask, the technique that I learned a while ago is for at-home stuff that's not like needs a sensor clean, but this thing was just floating around in there. I take the lens off and lock the shutter open and hold it so it's facing down, and then use a rocket blower to blow up into the sensor area. Is that good, bad?
Yeah, look, yes and no. So what you're doing and the technique to do that is a good way to clean dust out, because, you know, especially large particles, they're going to drop down when you hit it with the air blower. However, trying to squeeze an air blower like that and keep the tip of it far enough away from the sensor but still close enough to be effective can be dangerous. So all of a sudden you've pushed the tip into your sensor. You're better off doing it straight down. Around the sensor itself, in all digital cameras around here, inside the camera is normally double-sided tape that remain tacky for its life. And so any particles that are on here that go to here are going to stick to that. So you don't have to worry about it going into the camera and showing up later. It normally stays in that section and it doesn't come out. When I say most, okay, so we can't, not all, but most of them do. Certainly all major brands that we'll be using. So cleaning blower is great. You can get hairs that sit in the gate of the shutter, and sometimes move around, but they might be stuck on that little sticky thing and just floating. And as it comes close to the sensor, it then creates that shadow. And even at f4, you'll see those sort of things. A hair is absolutely huge to a 24 megapixel camera, so you will see. Now, you don't want to go in with tweezers, or you can, depends on how steady you are. You know, if you're a surgeon,
not that steady. My hand will be.
The closer you go, the more you're going to shake. So you're better off using something that's. You could use a cotton bud to get around the edge, but as soon as you touch the sensor, you're going to smudge it, because cotton buds aren't that clean and they are furry a bit themselves. So the thing to do is, like you said, with the blower and a tip on the blowers, is they're great, but they've got a valve at the end, and that valve sucks the air in. So you squeeze it, it blows out. You open it, it sucks in from the top. So make sure that your blower is kept in a sealed Ziploc bag, because it's going to pick up dust from sitting in your camera case, and as soon as you blow it, you put more dust in there. So keep it in a Ziploc sealed bag, and it'll do a better job for you. When you do get to a situation, if you've got to get, and you're in the field, and I think it's unrealistic that you have to go to a service centre to get them cleaned. So we encourage people, if they want, to use something like this, which is just a microfiber swab. And you can use these things at first dry, and you can touch the sensor with them safely. Keep this clean. This should be always in a sealed bag. You can buy them singularly sealed, pull it out, use it a few times. Don't throw it away. Use it for cleaning the outside of your camera, but never for cleaning a sensor again. These are really good for getting those hairs around the edge, or the big things that you can see. So, and you can use them dry. They're quite safe. If you've got a wet substance on your sensor, doesn't matter what you use, this or anything else is just going to smudge it, and you're going to have to get it professionally cleaned. But if it's just a piece of dust, this will remove it. Now, what I'm telling you is something that could be dangerous. So here we go. If you're going to go into a sensor to clean it with something that physically touches the actual glass, then you've got to be sure of what you're cleaning, because as you understand, on your bayonet mounts of your cameras, they're brass. They're nickel-plated brass, and every time you put a lens on, you're going to wear that brass, and you'll get swarf, tiny little particles of brass that go in to your light trap area, or your imaging area, and that could be on your sensor. So if you're going to use this to wipe your sensor screen surface, and there's a bit of brass swarf there, you'll scratch it. So if it looks shiny and a goldish color, it's likely brass. So you do what you said before, Justin, is that you use your blower and you go hard, and you go at least 5 or 6 times, and you're trying to shift everything that's there. And if it's a brass particle, it will move, and you'll be safe. But you need to be able to be sure and see it. Good eyesight. If you don't have good eyesight for that, you need to use a magnifier and lots of light. We have sensor loops, which you've got.
Oh, cool.
Yeah, a bunch of LEDs on the top, and we'll focus at quite a close distance. Where they could probably, it's going to be too bright with the camera. Oh, yeah, look at that. Almost.
Oh, wow. Yep.
That's awesome.
Yeah. So they're really good. They're 7 times magnification. We modify them. They take just replaceable batteries. We modify them. That's what we use to check the sensors visually all the time. And then we have a special microscope and a dust-free A-class chamber as well for doing sensors. But you can get those sort of things. They're about $90. These sort of things, $2 or $3.
They're on Amazon.
Yeah. Yep. Exactly. Yep. And then there's the fluids that you use them wet. So we can go into that, but it's another level cleaning them wet.
I was going to say, is that kind of the line where you're like, unless you're really confident and really want to dig into this, that's kind of the line where you recommend people hand it off to a service center, that kind of wet cleaning line?
Yeah, we see most of the mistakes done with wet cleaning. They come in and they're just, it's like someone's vomited on it. Not a good look.
Especially under the microscope.
Yeah, absolutely. Yeah.
Is that carrot? Is that a chunk of carrot?
I don't remember eating that.
Yeah.
Oh, no.
We've all been there. Wow, that's amazing. That's amazing advice. And those microfiber swabs are actually, you can just get them off Amazon.
I've been too scared to touch a sensor to clean it. I've had both directions told at me over the years. People have said, I've had people just say, it's easy. Just clean your own sensors. You just buy a cleaning kit, a wet cleaning kit, and you just clean them. And
there's
then
a lot
of
good
other
instructions
side.
out there.
I know, but I've had people say, never ever touch the sensor. I'm going to buy some of these. I think that'll be my line. I'm happy to do it. Maybe a dry swab. But I don't want to end up dealing with streaky marks and all that stuff.
You're right, Justin. And I'll tell you, Greg and Justin and the audience, you'll see there's a lot of videos out there with people using these and how to use them. The one thing they don't tell you about is that the amount of pressure that you put on these things. You shouldn't be putting pressure so the tip bends. That's way too much. You can barely feel it. If you run it on your skin and you can just feel it, that's it. If you're going harder than that, you're going to risk scratching your sensor. Some sensors are damn soft. And I can tell you a little bit about the sensor surfaces when we get to the crutch of the podcast, that is conversions. You've noticed the tip on this one? See how it's bent?
Yeah.
If you've got these things when you buy them, they're normally straight. And when you're straight, you're working on a tiny little edge just here. Right? Yeah. And that's where a seam is. I don't like to work that edge. It's nasty. So a tip for your tip is bend it up and use a small flat surface there. Much better. And you can use another swab to bend it up rather than touch it with your finger. Because
I was about to ask that. So you wouldn't want to touch this thing at all. You want to basically take it fresh out of the packet, use another one to bend it, and then do your clean, and then one clean. And did you say one clean and then use it for other things, or
you can use it for other things. So you'll get when I say one clean, you might spend the first time that you do a sensor clean, you might spend 10 minutes puffing around trying to get the little dust out there, and sometimes you get static build up and it follows you around, and it's really frustrating, but you will get there eventually. And sometimes you don't get it off the surface, but you've moved it to the side and it's outside the imaging area. So when you look at a sensor, inside the sensor there's a dark section in the middle. Probably can't see it well enough on the screen. Oh, you can
Oh,
just
yeah.
see that line.
Yep.
That dark center part, that's the sensing imaging area. That lighter part is not.
Right.
So if you bring your dust to the outside edge, you won't see it. So don't try and freak out to get it out of there. Just move it to the side, and then keep shooting. This is when you desperately need to get a shot done, and you got dust there, especially if you're doing video and you're in field. If you can take it to a service center, do that. That's their stress, and if they damage a sensor, they'll replace it. And you don't want to replace a sensor because generally they're half the price of the camera.
Yeah.
And they don't devalue. So you buy a $9,000, 1DX camera from you, and the sensor's still based on that original price, even though the camera devalues, parts don't.
Really? So you basically get to the point where you just buy a second-hand camera instead of replacing
Yeah.
the sensor.
Yeah.
Wow.
Yep.
Nuts.
That's very cool.
Wow. That info is gold. And look, Bruce's comment here, it's exactly what I was thinking the whole time through. Bruce says, I can see a bunch of shorts coming with this info. That's exactly what I was thinking. I was like, I'm going to have to clip this bit. I have to clip this bit. This is, it's gold.
It is gold. Let's shift to lenses. So tell me about some of the repair work that you've come across with lenses that you think if photographers had only done this or had only known this, it wouldn't have happened. What can you help us out with there?
Sure. So one of there's three common problems that you see. You're going to get those three fingers up. Three common problems that you see with lenses, and that is it's point of focus, optical haze, so resolution, and mechanical failures with them, like mechanical movements. They're the main things that we see with them. So when we get a lens in, particularly if it's for a focusing issue, we need to determine whether it's focus or whether it's resolution that we're talking about. And they're quite a different thing. When it's focus, something before or after the subject will be sharp. Of course, the subject's not sharp, otherwise you wouldn't be bringing it in with concerns. But if it's back focusing and your ears are sharp instead of the eyes on a portrait, or which is often the case with a lot of lenses, they tend to back focus more than they do forward focus, and that's to do with light frequency and the focus sensors and things like that. There's quite a few things. For example, we'll say about light frequency, just to touch on that briefly, is that if you're shooting in a light frequency that's got a lot of red, you'll tend to get a little bit more back focusing than you will if you do it with something that's very cold and it's got a lot of white light in it, or blue light. It'll tend to go front because of the frequencies and the focusing sensors in them. They're sensitive to color. So,
and it can be that much of a variation that it would be, it could be noticeable both directions depending on the, I didn't know that.
And we have special lights for our focusing targets that are multi-spectrum, because just white light alone, particularly LEDs, don't cut it. They're not like daylight at all. They're quite cold. They don't have a lot of red in them, and they don't have the near infrared at all. So we've added that to our focusing system, because you focus inside and then you go outside, you get different results. And we're talking about f1.2 lenses,
which is what, okay. So just for some context, the reason I'm slapping my face, for some context, when I was shooting Nikon, we loved shooting primes, and we were using a range of primes, but a lot with the Nikon 58mm 1.4, which is quite soft, wide open anyway, but a beautiful lens.
And Creamalicious, we call it.
Well, I shouldn't have sold it. It was a beautiful lens. Loved shooting it at about f2. And then we also used the 28mm 1.4 and the 105 1.4 all the time for weddings. And various times with various bodies, we were trying to fine tune the what's the word, the setting, microfocus.
Microfocus, yep.
Microfocus, and we were trying to do that ourselves manually under, and now I realize, under LED fluoro tubes in our office. That was the only light I ever tested it in ever. We never, because we only ever did it inside, just because I don't know, I didn't even think that would have any relevance at all on what we were doing.
Get outside, it's back focusing, right?
I had no idea that would have any impact on it at all. We just set up a tripod and we're like, all right, I think we can just keep playing around till we get this thing dialed in. And then, yeah, you'd go and shoot a wedding. And you're like, oh, it's still just not quite, not quite right.
Yep. Yeah. I'll share a tip, a way to do your focus optimization or your focus fine tune in a little bit. So back to the question about lenses. So we're talking about point of focus. That's one thing. And just to give you an understanding is that the lens has a focusing motor in it, ultrasonic, silent wave, all of those types are all the same principle. Then they've got a driving circuit for that, and then they've got a feedback circuit inside there, which is called a magnetic reader, and it detects how much the focusing unit has moved by feeding back to the lens control circuit, then ultimately back to the camera. So what happens is that the camera says, focus here, and the lens go, all right, I'm there. But the lens will go, I've got a built-in correction. I'm going to go here. No, I'm going to actually go here because it's got a predetermined factory built-in correction for that. So when the lens gets to that point, it says, all right, I'm there now, take the shot, and the body takes the photograph. But the lens might have a forward and back focus correction in that, and it's a focus aberration. We can change that focus aberration, and we can check that it's central and it's doing its job. So that's really important, and because that affects your depth of field, you should have like 1/3 forward, 2/3 back depth of field. We can shift that a little bit, play with it, and also that should be constant at different zoom ranges. So it should focus track. So again, that is a calibration process. So we make sure that the focus aberration correction is as it should be, and we use what we call God bodies or son of God bodies. And these are very expensive tools that give us an absolute. And so that's what all of your lenses are tested on. When we do calibrate a lens, we calibrate the lens, and then we calibrate the camera. This is for a client's kit. And if we've done our job properly, we bring them together and they should be spot on. So they're all calibrated to a standard, and that's according to Nikon, Canon, Sony, whatever the brand is. So we use that factory standard to calibrate, and we bring the kit together, and then it doesn't matter if you buy another lens, it's still the same standard. You've got focus as one issue, and you've got resolution as the other issue. And the resolution can often be confused as focus. But in resolution, nothing's sharp. Doesn't matter forward or back, nothing is really pin sharp. Determining the type of resolution issue is also challenging, and that may be optical pollution, but it also be camera blur and motion blur, because you can shift, say, circle of confusion to maybe 4 pixels, and it's really hard to tell that's motion blur, but you can certainly see that it's not sharp. We tend to ask for images from clients because if we're doing a focus optimization on a kit and it's actually just motion blur, we're chasing our tails and we're not going to achieve anything better. But if we can say, get it off 1/20th of a second, push it to 250 or 500th, and you'll save yourself a lot of grief. So they're the things. Now, optical pollution, what causes those? Heaps. There's so many factors to it, and it can be anything from fungus, internal haze in the optics over decades of use. It could be degradation of the coating, or it could be just a crappy filter. And crappy filters cause a lot of problems.
Oh, let's talk about filters. Yes. Yeah. Let's talk just quickly. I don't want to derail the lens stuff too much, but there's 2 schools of thought with filters. One is get a decent filter. It's not going to affect your image quality. And I have personally smashed multiple B+W filters that would have otherwise been the front element of a $4,000 lens, because I'm very clumsy and I shoot a lot of mountain biking, and I've done it twice. Anyway. So all right. There's that school of thought, and then there's the other school of thought, just quickly to set the picture, is why would you ever put a filter that cost a couple of $100 in front of a $4,000 piece of glass that was painstakingly, laboriously perfected in a factory? What are your thoughts?
Okay, so there's the filter, to filter or not to filter is the question. Simply this is that if you're the quality of the filter is not going to affect let me word this in a way that's kind to filter manufacturers as well. You spend a lot of money on a decent filter, you're not going to see a lot of difference in your results. In actual fact, you'll be pushing to see the difference at all. It's an audio buff that's buying wires for their speakers that don't have oxygen in them. You just can't hear the difference. It lasts longer, sure, but you can't hear the difference. You won't see the difference between those really high quality, expensive filters on a good piece of glass. The glass is good as it is. You don't put a filter on it to make it any better. You put a filter in it to reduce the frequency of light coming through. So you've got filters that have, optical pollution reduction, haze reduction. They're just cutting out frequencies of light that may be scattering because it's hitting the atmosphere. So you're actually reducing the overall color that comes through the lens, or the frequency that comes through the lens. Now, if it looks better for you, do it, fine, not a problem. Yeah. But you're eating vitamins, you're just having expensive pee if you don't need it.
I love that. That's great.
Or what about though clear protection filters? So because there's some companies that sell clear protection filters, no UV. When I started, UV filters were kind of the default protector. Was a UV filter, but then companies started making clear protection filters. I don't know if they still cut out any light or not, but
so you're right, Justin. In that their filters have to have a coating on them, otherwise they have a really poor diffractive index and you lose light. So every piece of glass that you put in front of your camera, you're going to degrade the image. You're going to change the light coming into it. So it will defer the angle of light for the period of time. So here's your filter thickness, and here's your light coming on this angle. As it travels through the filter, it straightens up, and when it comes out the filter, the angle of light comes out there. So it changes for a brief moment of time, that angle. And in that angle diffraction, you can have some of it disappear. It might only be, 0.6% or 0.9% on, 0.6 on a really good filter, maybe 0.9 on an average filter. And that's to do with the multi-coating on the front of the filter and the back of the filter too. So your clear filters have to be coated. A coating takes away frequency. It has to. It can't not. Are the cameras sensitive to that frequency? Yes, they are, but very limited. So do you notice it? No, you don't. So you can put a filter on and not notice much difference in your image, very little at all. Why are you putting a filter on in the first place? It's not to improve the image quality, because we've concluded that it won't. It's there for protection. That's a good option. That's a good reason to put a filter on, is for protection. We cut off heaps of filters regularly. It's 2 or 3 times a week we're cutting a broken filter off or damaged one, which are really hard to get off. Okay. Yeah. We've got some neat techniques for that.
Yep. I've had to cut one of mine off.
Yeah.
Because I was in the field. I was away from home on a car trip, dropped the lens out of the boot, getting it out of the back of the car, and permanent filter attachment. It's one of those, the camera is one of those tools that get dropped sometimes. So the filter crack, trying to get that off. And I tip on that too. If you grab hold of a lens, you want to hold it as close to the filter as possible to remove it. If it's a zoom, extend the zoom, grab hold of the front and then try and remove it. Because if you put pressure and it's retracted, you're going to strain the mechanism deep inside that lens. And they're very small rollers and thin pieces of metal because they're lightweight and have to move quickly. So you can really damage the stuff. So grab it as close to the filter as possible, then wrench it open. So back to the quality. Filters are great on lenses that aren't tele. So if you'll put a filter on a lens that's sort of intermediate to wide, sort of up to 180 mil, anything from 180 mil and above, I wouldn't put a filter on it, because there's very few filters that don't affect the image and create a ghost on those lenses. You got a 200 mil or 200 to 500 mil lens and you got a filter on it. We get them, probably maybe every second week, a lens that's got a filter on it that's creating a slight ghost image and reducing the resolution. Take the filter off and it's perfect. So if you're concerned about your image quality, put your with a filter, and you've got a tele zoom lens,
put the camera on a tripod, focus absolute. If you want to focus absolute, do it off the sensor. So it's either live view, or if you've got mirrorless, it is always off the sensor focusing. Take a shot with and without the filter, wide open aperture, and have a close look at those images. Take 5 shots of each in case you've got some camera movement. But do that and then decide whether your filter's doing it or not, because we've got really expensive filters that bugger up an image and give you a double ghost effect, and we've got some pretty basic, inexpensive ones that don't. So you just can't tell until you put it on it. It's a weird phenomena that's to do with the Nyquist frequency of the sensor, the lens and the filter together. They have an interference, sort of a phase effect.
Right. So it's not a matter of me saying, okay, Wayne, what's the best filter to buy? It's a filter and lens combination issue that could be different depending on that lens, that filter. There is you couldn't give us a recommendation of a brand, say, oh, those filters have the least issues, because it's not. No. Yeah.
And if I did, it'd be our filters that we sell.
Do you sell filters?
Yeah. We've got a range of filters that we keep that I've been testing over the years. We're working on our website, and we haven't commercialized this yet, but they're filters that I will sell that I know that have the least amount of effect on tele lenses.
Wow.
In our experience,
Yep.
Would a lens hood be just a better, like a lens hood gives you a bit of protection in the sense that it's it protrudes past the front of the the optic, so it's like the chances of breaking that or damaging it when you've got a hood on. Is that what you'd recommend in general for like a tele? Just have your
hoods
have
are
your hood
great.
on?
Yeah. However, let's flip to the next side of that. Is that if you got a hood on the front and you give it a whack. Now I've seen, for decades I've been working the Grand Prix at Phillip Island here and doing service work on-site service work, and I remember that all the photographers would rush in, bring their gear in, get the next set of lenses because they've got another race coming and they want to go out to a different straight and they'll need a 600 instead of a 400. And I remember a photographer coming in with his 2 lenses sticking out, one hanging on each side like this over the strap and the lenses out. And he's walking into the portable booth, which was our service department in there. And one lens goes whack on the door frame right on the tip, and the other lens, and he looks, and he goes bang, and the other side, the other lens hits.
Oh no!
Bent both the bayonet mounts and broke the hood. So the hoods were sticking out. Now that's what you normally have. The hoods are held on with a bayonet system, and they're plastic. You can often what happens is the hood doesn't break because they're pretty tough things. Is that the actual bayonet mount lugs that are on the front of your lens break off, and that's more expensive to repair than a filter that's busted. So when you're not using your hood, turn it around the other way so it's facing inside the lens as they're designed to do, and you're less likely to hit that and break it. So hoods, filters, lenses. So we were talking about resolution and haze. Shine a torch through a lens and you'll see everything, and then you'll freak out. And then you'll bring it into a service center and say, look, it's not that bad really. But yeah, that's what we do. We'll use a dynamic, polarized light through the lens to see the state of the optics. Sometimes you can't see it very clearly, and some haze and residue, which comes from the gases that are built up inside the lenses when they're used over years, when they're hot. Put a lens in Queensland, you get different results to a lens in Melbourne. In the use, because of the temperature and humidity. Some materials, like the inside of your windscreen, build up a film of gunk and muck, and you rub it with your hand and you'll see that smears. That's from the dashboard of your car as the heat rises and it deposits on the inside of your glass. And your Armor Roll's classic for doing that. Makes your dash look nice, but it creates a film on the inside of your windscreen. So cameras aren't much different inside. So the materials that are inside the lenses over 5-10 years can produce a type of a film or gas. They don't want that, and they'll do everything they can to design, they being the manufacturers, to design to remove that. But it's sometimes inevitable, the black paint around the edge, things like that. So Haze. Yeah, we determine the haze and then make sure that we can remove it. Sometimes it's in the balsam, which is where the two elements are glued together. And years ago, they used to use a product called Canadian balsam. Now they use a UV glue. Sometimes that separates or goes yellow, and then you get other artifacts in there, especially with people using those classic primes, because we do a lot of cine mods. So cinema photographers love those lenses. Even to this point where they'll buy a range of lenses with similar serial numbers because they've got the same color tone. They're made with the same coating in manufacturing. So they've got a similar look, very specific.
That brings me to a question about lenses, or two questions that are kind of related. I've had multiple lenses, different ones, that have had an issue where one, say if I'm focusing in the center of a group, and I was half reasonable at wedding photography, so the group was perpendicular to the image sensor. They should be standing all in focus quite nicely, but focus would drop away on one side of the frame. And I think, is that called astigmatism? Is it the same as, is that what that is? When one side is in focus and the other? Yeah. Is that the same as that? Or is that, what is that called?
Yeah, so that sort of leads us into the third thing that we're talking about, which is the movement. And the mechanical movement of a lens is really critical. They're highly tuned, finely adjusted optical blocks that sit on very small rings, which are called rollers, and they shouldn't be called rollers because they just slide. They don't actually spin. They've got a Teflon bush around them, and they just slide in a channel. I don't have a prop for that, but as you zoom in and out, these things slide. They become worn. If you knock the lens, they become distorted, and things get bent. So what you're talking about is an edge-to-edge focus resolve, and it's just not there. So on your focusing plane, so is the camera here looking down, focusing on a plane, your camera's doing that. But your subject's still here, but the camera's actually doing that. It's focusing. So it's before or after the subject on the edges that's actually sharp, but not where you want it to be. Or it's that bad that it's actually, the edges are just off. Now, a simple check to see that, we have special targets that tell us whether it's forward or back on the edges. We also have a high resolution projection unit. And that's how we calibrate the lenses on a projector. We project a resolution target through the lens, and we look at it at the other end with special high definition cameras on a wall. So we've got a screen and we can see 9 points on the lens. Back to your issue, you can do a simple check. Anyone can do this. Lens, aperture priority, wide open aperture on the body. Doesn't matter about the shutter speed. Oh, you want it fairly fast. You don't want to have movement. Photograph a brick wall and you've got to be perfectly parallel. So you have to get in the viewfinder the bricks at the top and down the side to be perfectly parallel to the frame line. Photograph that and then bring it up in your computer and look at the edges. They should all be the same. They should be all sharp. If they're not, then you've got an issue if it falls off. And that can be substantial as in the repair for those, because most of the time it's impact. If you're lucky, it's a bent bayonet mount, which is the sacrificial lamb of a lens when you get impact. A bit like the hot shoe used to be on flash units, except they're metal now, so they tend to rip off the top cover instead. But yeah, lenses, the bayonet mount, bend that, replace it, sure. But then if it's something else, then it's really critical that we get all of those optical blocks perfectly parallel without a twist or a bend. And then there's a centering access as well where you cause flare. So the adjustment is hours and sometimes 3, you know, just to do the calibration of these high resolution, high resolving lenses. And why are they high resolving lenses? Because we've got friggin' 61 megapixel sensors now that show up any defect in a lens. So the lenses have to match the sensors. So,
I distinctly remember one of the lenses. It was a 24-120 Nikon F mount F4, which is like a kit lens of their Pro series or whatever. Like they do it all. It was a nice lens, but I think I might have even had 2 of them. And this was the question I wanted to ask, because this was happening since new that I got it. It seems to be less of a theme these days, but when I started, which wasn't that long ago, around 2010, this whole talk of I got a good copy of that lens. You know, I had to buy 3 of them, and then I ended up with a good copy, and it's great. You know, it's amazing of various lenses. But you would hear that online regularly in, I don't know, forums and things like that. Is that real? Is that a myth? Is this manufacturing
a Wednesday
tolerances?
lens or something, or a Monday lens?
Yeah. I got a good one, and then I got a bad one. It was terrible, and I wondered whether this issue that seemed to be on this one lens, is it just every now and then manufacturing doesn't go to plan, and it's just slightly out or something. Yeah, what's the deal with that?
There's price point lenses in manufacturing, and there's manufacturing at price points. Okay, and what determines that is the build quality and the design and the checking. And part of that process of checking is your Q&A and your edge-to-edge resolution. So for a lens or body, that could be manufacturing anything. They all have got price points. You're going to get to a situation that, you know, there's a 50 mil f.95 Noc Deluxe Leica lens, and it's over 20K. It's over 20K for a reason, because it's just, you know, those checking procedures and the build quality are all there. There's high resolution quality lenses in all manufacturers, and the time and the care to get them to that stage is there, and it always is and will be. There'll be differences between the focusing on the plane and the autofocus sensor in the camera. For mirrorless, you have less issues. But I mentioned before about the focus aberration, that adjustment that's inside the lens. There's also one inside a body as well. Now, if they don't match, if you've got one that's got a plus tolerance and another one that's got another plus tolerance, you've got 2 pluses, and before you know it, your focus is back or front of the subject. And it's not because any one of them are particularly wrong. It's just that they've got a plus and minus tolerance, and they're both on the plus side, so it equals an error that's noticeable. If you get a lens and a body combination, that's the lens that's out, and you get another one and it's still out, and you get the final one and it looks great, it mightn't necessarily be the lens. It just might be you're getting 2 plus tolerances lenses and 1 minus. And the minus one looks really good on your body. It's still within the plus and minus tolerance that the manufacturers work to. But together with your body, then it looks out. So the most common scenario was that I dropped my lens. Oh, struth. I hope it's not buggered. And they've got the lens, it's got a wobble, and you get the lens in. No, it's not buggered, mate. It's all right. We can fix that. What about your body? Oh, I didn't think about that. It's truth. I better get the body in. So the body's taken a hit because it's been on the lens, and the bayonet mount is no longer flat. It's got a bend to it. So all of a sudden, that photograph that you were talking about where you've got the group of people and one side shaft, it's because of the body, not the lens, because the bayonet mount's bent or something, or the casting's bent, which is even more critical. So there's lots of aspects to it. If you ever get a knock on this precision piece of equipment, you get them both checked. It's as simple as that. And then you're sure. If you're not sure of the lens or body, you can do that simple test that I said about with the brick wall, shooting that, because that'll determine that lens is good. And you put your next lens on it and it's bad, then you know it's the lens, not the body. But if you put every lens on it that's bad, then your body's needs some attention.
Wow,
and
that's really fascinating.
Age, I was going to say, when we get to a certain age, all of our bodies need attention.
Yeah, they do. So with that in mind, you know, because and there's a comment here very quickly from Bruce. I just want to read this out because I think it's very apt. People forget how insane the engineering in lenses and cameras, I would say, and that they are precision devices. And it's amazing how far we've come with lens technology, I imagine. You know, people do forget about what's going on inside. And I've seen people rough handle gear, you know, and I wonder how many of those knocks. Yeah, Justin's one of them. No, but I've had people who don't put lens caps on any of their lenses, you know, like they'll have a Pelican case full of lenses sticking up and there'll be no lens caps on them. But when you're shooting with, say, a big, heavy super telephoto lens, how much pressure is that putting on that lens mount on the camera?
Oh, huge. Okay, so to put it in perspective, a 0.01 millimeter movement between the bayonet mount of the lens and the sensor, which is the focus plane, can result in a noticeable focus error. So we're talking about 0.01. Now, I remember spent down at the Grand Prix at Phillip Island, and there was a photographer that was having lots of focusing issues. And it wasn't until I went out with him shooting to actually understand the technique. And he was a big fella, and he would rest his arm on the front of the lens while shooting, and it was on a monopod, and he put that much pressure on it that it was actually separating the bayonet mount and the lens enough to cause focusing issues. So the further away, here's our makeshift lens, here's our body. So the further away that the lens goes from the bayonet mount, the closer the focus becomes. So you'll have a front focus. So if your bayonet mount is bent forward, you'll have a front focus. If it's been slammed and hit this way and it's gone in, and the lens is going closer to the sensor, you'll be back focusing. So it goes closer to infinity. So that's the rule of thumb with those. But in answer to that, yeah, they are absolute precision, and they're very, very fine, and that's why it takes us hours, and that's why we use, we have special shims and special tools to check that and align things. But it's absolutely critical when you're shooting those wide open averages and you've got those fast primes to get everything spot on, not only just the coating to reduce your chromatic aberration and other things like that, but yeah, your edge-to-edge sharpness and the centering of the optics. And it is a tool that's some people are so passionate about what they're doing with it and invested in the image and the capture that the equipment is just a way to get it, and it's a tool. And it doesn't necessarily get the respect that it needs or deserves, but I love their passion, and they still get the shots. And they're really good customers because they come in more often than the others that look after their gear.
They care. Yeah. We talked earlier about dust in cameras. Is dust in lenses as big an issue anymore?
Yeah, huge. So you can't use a bike pump if the end of it's blocked. Same with a lens. If you don't have airflow through that lens, you can't zoom. It's as simple as that. So airflow means air currents. Air currents means particles of dust. Dust deposits on the optics, and you get haze. Dust inside optics causes flare, and you get this really soft image, and it affects your resolution greatly. So you hold it up to the light. When you hold a lens up to a light and you're looking for dust, you might use the torch, and you don't look directly at the torch. If you can see the torch through the tests you're doing, then you got that torch in the wrong angle. You've got to have that down. So the light is illuminating all of the elements through the lens. That's all it's doing. You can't see the actual end of the torch, and you're looking at the light falling on the actual optical elements for dust. And you can get some crazy amount of dust because some lenses have poor sealing. Some of them have very good seals that filter the dust as it goes through. They've got felts and other things. The design of the airflow should be that it doesn't go via the optics. It goes via some outside venting ports as such, but it still ends up coming out the back of the lens. It doesn't matter how you do it. So dust on the outside of your lens is as critical as the dust on that around your camera as well. So where you store it, clean that, wipe it out with a damp cloth, that sort of thing.
That's great advice.
Well, that brings me. Okay, I want to make sure we get to full spectrum conversions, because otherwise I can't spend all my money. But before that probably brings me to a good question about, so do you have any tips for photographers buying secondhand gear, whether it's lenses or camera bodies? Doesn't have to be too in depth, because I know there's probably a million things you could talk about. But like, what should people be really wary of if they're looking at buying particularly expensive secondhand gear? L series lenses or higher end bodies, to make sure that they don't buy something that's already got problems, I guess.
Yeah. So if it's very difficult to determine the state of the optics and the camera performance without using it. So if you're going to purchase something, you make sure that you've got the opportunity to take it back if it's not right. So you need to buy it from a reputable source, that will back up the purchaser and give you recall to get the product returned if it needs to. If it's a very expensive piece of equipment, just like I did with a car recently, I went and got it checked. It found a couple of problems, and then it was repaired under that warranty of the car. So same thing, get them checked if you're spending that sort of money to make sure it's all accurate and working well. A shutter count, we call it a SRT, shutter release times, is a good indication of how much use the body has had. Lenses, you're looking for wear, if they're plastic on the outside or even metal, scratches, shiny painted surfaces means that they've been handled a lot. Some people just handle their equipment a lot and don't necessarily take a lot of shots, but do handle. I remember seeing photographers, I'm just standing there talking to them, and they're constantly zooming the lens. So this is going to wear things out. It's as simple as that. As they're talking.
That's funny.
It's crazy. Yeah. But when the days, and I used to have hair, my hairdresser Con, he talked to you. He talked a lot. Lovely Greek guy, but his scissors are always going while he's talking. They move as much as his lips do.
That's great.
He's wearing out his scissors.
Yeah, exactly. Yeah. Secondhand equipment.
Yeah.
Okay.
Let's get into conversions, because it's been a topic on Justin's mind for God knows how long, and we've had a lot of people a lot of our folks in our community, in the audience, have or also interested in shooting at different spectrums of light. Tell us a little bit about what it is that Imaging by Design does for folks that want to look at doing infrared photography.
Yeah, sure, absolutely. So in the CMOS sensor, even the TTL sensor, they're all still made with silicon substrate transistors that have been modified as such or designed to capture photons. And they have a thing called a light well, and that is where the light is converted into electricity. And then from that, they get shifted off the sensor through a shift register out to a circuit, and it's converted into something that we can make sense of. And the light, when it hits the sensor, comes via several filters. One of them is part of the Bayer pattern, which is a red, green, blue. There's actually two green, one red, one blue. And together, those colors form a sort of group to work out what that one pixel is going to be, because it uses the adjacent pixels to say, oh, yeah, you're not red, you're not blue, you're somewhere in between, and you're going to be X. And that's a small, tiny little filter that fits on the front of each pixel. And then in front of that filter is a micro lens, which is a tiny little domed filter. When I say domed, these are 3 microns. Right? That's minuscule, absolutely tiny. So that domed filter lens that sits there focuses the light into the doped filter that then goes into the light well of the CMOS sensor, and it captures the photons. Now, the reason that the lens at the top is there is because they're fairly deep, the gap between the top and the photon where the light goes down. So we're distracting from this a little bit, and I don't want to get too technical, but you've got your dope filter, red, green, blue, right? Bayer pattern after Frank Bayer, who invented that. And then you've got your bandpass filter that sits in. Step back, we've got a cover glass filter that sits on top of the sensor, and it's just a plain piece of glass. When I say plain, it has to have a multi-coating on it, and they have to have a multi-coating to get the refractive index, that is the amount of light that passes through and doesn't reflect off, as high as possible, because you don't want to lose light. So there's a piece of glass that sits on the front of the sensor, and your sensor might be something like this. And I'll show you the surface of this one, because this one here is very, can you see that? Try and get the light in there. You can see all the lines of rubbish in it.
Yeah.
It's a very buggered sensor.
That is very buggered.
So that top is, because I'd heard that rumor too, and I never wanted to believe it, or I didn't want to take the risk. But the rumor was that bit, if you did put your thumbprint on a sensor, that's not on the sensor itself. It's on a glass cover, and so that is correct.
Yep. That's correct. Yeah. So then you don't get close to the pixels. They're protected by a cover glass that seals the sensor, and no dust can get in there. If you did, that'd be so sharp you couldn't get rid of it. It's a nightmare. We've had a bit of fun converting cameras to monochrome sensors. So we've been obliterating. We don't make it commercially available, but we're just nuts here, and we like to do stuff like that. Even putting liquid cooling through cameras and stuff like that. So anyway, we've been removing the dope filters on there with an ultraviolet laser, and we blast them off and then wash the sensor down to remove all the debris, and you have a monochrome sensor. You're still dealing with an RGB output because you can't change that, but it's still a lot of fun, and it's a very sharp sensor, and you've just got levels of gray, you've got levels of light, and they're just incredible, the detail you get compared to what you have if you've got a filter in front. Okay, let's get back to our conversion. So on the humble sensor, you've got a bandpass filter. Here's one we prepared earlier. This piece of glass sits on front of the sensor at a distance, and this is a thickness, and they're all critical because they affect your focus. Remember what I said earlier is that when light passes through this, it then changes its angle and then exits out. That distance of the thickness of the filter determines the difference of point of focus. So you have a big piece of glass here, your focus point will be here. A thin piece of glass, the focus point changes to do with the thickness. So that's critical that this glass thickness is maintained when we do a sensor conversion. So we remove this. Some cameras have two. Some cameras only have one. So this is out of a Sony A7R Mark III, and that's about 1.8 millimeters thick, and it's got multiple pieces of glass in there. This one here is out of a GFX 100 Fuji.
Ooh, look how big it is.
That's got two pieces of glass in it, and it's got this one plus another one. And the second piece of glass often, you see that bit of wire sitting out of here on this one?
Yep.
That's the ultrasonic clean. So what this is there's a piezoelectric crystal adhesion down the side. You put in voltage and frequency, and this piezoelectric crystal flexes really quickly. It sort of does a wave like this. That wave travels across the sensor in a vibration and makes the whole thing shake, and then your dust is supposed to fall off like that. It's good for big particles of dust, the ultrasonic clean mode or the cleaning mode cameras. It's good for big bits of dust, but the small stuff, it's crap.
I actually have a quick question on that for my Canon specifically. I have it set to clean when you power the camera down. There's multiple settings for I assume it's a similar technology that they use, or is it the IBIS or something that they use to?
Oh, no, you're right. Yes, there is two different techniques. Yep.
Okay. Either way, it takes a couple of seconds, and because I get so much dust on the camera, I've got it set when I power down to do that. But also I'm powering down to change lenses, and it's taking me 2 seconds to wait for the shutter to snap closed, because the shutter doesn't snap closed until it finishes its little clean cycle. And I'm trying to decide, do I ditch the clean cycle so that I can change lenses with the shutter closed faster, and that's probably better for getting less dust in, or do I need to keep that clean cycle going to minimize dust sticking, as I'm changing lenses?
Yeah. Look, the ultrasonic clean, the clean mode, whether it's using the stabilization of the sensor and to shake the whole thing, which is using a magnetic field to do that, and it goes thump, 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 and it cleans it. It's a bit like, sort of like bang, bang on a bench like that, and some of it drops off, or it's shaking the physical piece of glass at a high frequency and it falls off. For large particles of dust, those meteorites that are in there that you don't want to show up, and that even at f8, it's good for getting rid of those. It has to have weight to be effective. When I say weight, the particles have to have some weight in it to be effectively removed with this technique. Anything that's light and sticky, forget it, just stays there and you've got to wipe it off. So
that's actually a good point, because this when I had this little hair issue earlier this week, it probably went through that cleaning cycle 10 times while I was changing lenses various times through the day, and that hair was there all day. So it didn't get rid of that.
And it's most likely it was on the gate of the shutter and not even on the sensor itself, and just it was because it hairs have got curl.
I could see it on the sensor when I cleaned it. I could I could visually see it from this far away. It was it was massive, and it was just sitting there on the sensor. And the clean didn't do anything, but then when I squirted it with the rocket blower, it come straight off. It wasn't sticky at all.
What I don't understand is why manufacturers don't have a static charge that they can introduce onto the sensors and get that, because most of the time the dust is stuck there because of static differential, and we can use static or anti-static guns to remove dust. You wave it over there and the dust just stands up and it dances across the sensor towards the static gun that we're using. The issue with using a static gun in a camera, it can destroy the circuit because it is high voltage and static. So, we do it for certain techniques of cleaning of certain optics that don't have electronics in it. And we use special anti-static cleaning booths as well that ionize the air. The clean mode, turn it on or off. But you might as well have it on because it's not going to do any harm. And just wait for it to finish and then change the lens.
Just be patient. Okay.
Be patient. Yeah. I'm going to get this next shot. I got to change it.
I couldn't talk to that.
All right.
We want to get rid of this.
Conversions.
Yeah, we want to get rid of this, and we want to put in something that I didn't bring with me, but we want to put in a piece of glass that we have custom built and made for our sensor conversions. And it might be just an infrared piece of glass like this. Is obviously a filter, but we'll have them at a particular shape and size and thickness. And we've got thousands of bits of glass up there upstairs of different frequencies. The typical frequencies that we stock are 590, and we're talking about nanometers here, so 590 deep orange, 680 red, 720 deep red. All of these go from that frequency and above, so they go there to the near infrared range. They cut everything from that frequency and below. Okay. We have then 780, which is infrared only, no visible. 850 deep black and white infrared results, and then you've got a 920 nanometers, which is really deep, which is IR, getting a little bit closer to your short wave. It's still away from it, but it's quite a dark tinted dark glass that you need a lot of infrared to use. Normally they're scientific use. So going back to the filters at the other end, then we have full spectrum, which is either quartz or plain boresight glass of some sort, and that it has no coating on it at all, no anti-reflective coating, nothing. It's just straight glass. We use quartz because it gives the highest transmission of ultraviolet. It's also a hard glass as well. And then we have UV glass, which is quite specific and expensive as well. So it only allows ultraviolet light to pass. And often they're in the form, like here's a UV 365 filter. So nothing gets through that, only 365 nanometers plus or minus 10, like a bandwidth of about 15 nanometers. And to get that piece of glass without transmission of infrared is really quite a task, and it ends up being, a $400 filter for that sort of thing.
Right.
So once we remove the bandpass filter, and we do this, it's a two-state process. Is that camera comes in, it gets checked. First of all, we communicate with the customer what they want, and we often ask questions, what are you trying to achieve? Because it's, what they think they want and what they're actually going to achieve can be sometimes two different things. So we just try and filter out that anticipation. And the camera goes into the workshop and the technician checks the equipment, does a full confirmation that everything's working. Then the sensors, the camera is dismantled and it travels in a special anti-static box with all of the screws separated, and the sensors removed, and it goes into the conversion department. which is an area where we have our clean booth and all our glass. So then the glass is, so we check that we've got the right piece of equipment, the right sensor, and we know what frequency, and it's in stock. If it's not in stock, then we'll order it in and communicate with the customer. Then what happens is that the sensor gets dismantled, the glass is removed, and this is done in the cleaning booth, the A-class cleaning booth, because you can't afford to get any dust in there. You can't see the dust that will affect the image. And because it's so close to the sensor, there's zero dust in there. It has to be, otherwise you'll see it. We fit the glass, which has been already cut to size. We might use, we'll use a laser cutter to cut the glass to size, perhaps grind the edge. We often blacken the edges, especially in the full spectrum conversions, because you can get light hit the edge of the glass and bounce off and cause a ghost or a reflection inside. So we'll often tint that. And then the glass is fitted to the sensor underneath a microscope in the cleaning booth. So we've got a special viewer to do that. The issue with doing this is that when you're doing an IR glass, you can't see through it. So you don't know if there's any dust underneath. It shouldn't be, but you need to check. So then we have infrared microscopes that we can see underneath this filter to the sensor surface to see if there's any particles of dust in there before it goes out. And that's the really critical part. Then it gets sealed, adhesion put back around it, because they've got glue around the glass as well. You can't just take this piece of glass off. It's glued on, so you're heating the sensor glass to 90 degrees, 100 degrees to actually soften the glue, the double-sided tape, to peel it off. And you got to do that with some pieces of glass which are only 0.5 mil thick, and they crack really easy, so you have to be careful to break them. But yeah, once that's done, then that goes back to the technician and reassemble, and they go through the checks of focus, dust. They'll set a custom white balance and do the calibration that's required either for the focus or the actual exposure, because the exposure can change as well. So that's what typically what's happened. Now, because the sensor is made of silicon, has a base sensitivity of about 780 nanometers. It's actually as sensitive to infrared as it is to visible light. Its other peak sensitivity is green. So doing an IR conversion, you can go outside with the camera and the exposures are exactly the same as what it would be during your daylight photography. Keep in mind that outdoors you've got tons of IR light from our big wonderful sun. Indoors, particularly LEDs, you don't. There's no infrared light in LED lighting at all. So you try and take a infrared converted camera inside and take shots, you get not very much at all. You need to illuminate it with maybe something like an IR torch. I know you can just see that.
Oh, yeah.
Oh, wow.
Now, the reason that this is happening is because my camera on my computer it's sensitive to infrared. It's got a bandpass filter on it, but it's specifically one that I chose that doesn't have much block of the infrared range, so you can actually see this torch quite brightly. Now this filter, I put that in front, all of a sudden you can't see, you can just see the LED inside. Now that's on. Take it out.
Crazy.
There it is. So this bandpass filter is blocking the IR. Now if I put this IR filter on the front, you can still see. Still see the light. Not as bright, but you can still see it.
Yeah.
All right. To quickly recap and clarify some of this stuff for myself and maybe some listeners. So there's a filter over the sensor in our cameras that lets visible light through and cuts some of the infrared light from the factory. That's just how they operate.
Correct. And we refer to that, Justin, as the band pass filter. That's this
band pass filter.
Yeah,
right.
band pass filter. Yep.
And so that's why, because correct me if I'm wrong, I can buy some filters now that I can screw on the front of my lens to get some infrared results, but I would have to have a super long shutter speed because it's got to let so much light through because it's essentially working against the filter that's in the camera that's trying to block that light. Correct. So is that how those front mounted like filters work?
Yeah, correct. So the spectral range of a CMOS sensor or TTL sensor on CMOS is 330 nanometers is the lowest frequency it will be sensitive to, up to 1100 nanometers. So that's deep black and white infrared to UV. The bandpass filter, when you put that in front, cuts off that frequency to 600 and say about 650 nanometers deep red, and it starts, there we go, lovely, thank you for doing that. So it starts then at about 400 nanometers, 420 in actual fact, 420 nanometers. So in the violet to the red. And
okay. Right. This is graphics courtesy of David Leparati though, who's in the chat. He sent this through. I think he said it's out of a book that he's got about infrared light. So I'll have to find the name of that book again. But thanks for that, David. Anyway, sorry, Wayne. Go on.
Yeah. I know David was one that mentioned he does a lot of IR photography. So thank you.
Yes. Yeah, he does. Yeah.
So what we're looking at there, and you can see those two lines on the colored top bar chart. That's pretty much where sort of your camera sits in between those, a little bit more narrow than that, sort of 420 to about 650 is where the sensitivity normally sits, because that's what we see. There's no point in having a camera that sees more than what we, so that hence the reason the bandpass filter is made in that area. And there is a slight green tint to it because we see more green than any other color. So that's why they've got that actually, otherwise it wouldn't look natural to us. Now, the peak sensitivity of your digital camera is right in the middle there at the 520 odd nanometers in the green. However, it's also sensitive to 780 nanometers into the near infrared. Now that's blocked because of the bandpass filter, and we remove that and we can put a filter of choice in front of the sensor to then cut out all of the frequencies you don't want to see, like the visible, and only have infrared. Or you can have an option, which is a really cool option and it's become more and more popular, that we put a clear piece of glass in front, quartz, and that the client then can purchase their own filters in all these different types, and there's heaps of them, to put in front of the lens and change the frequency in which the camera can shoot. So you can actually put a filter like this one here, which will bring it back to normal visible light, or you might go your UV. This one here has UV and IR, and this is the classic IR chrome filter, which gives that look that's quite popular at the moment, which gives infrared and maintains some skin tone colors and things like that. So full spectrum has become popular. Straight out infrared, choose a frequency that gives you the look you want. Popular is 720 nanometers, and the reason why 720 nanometers is popular is because it lets in some visible light. So it means you can get false colors. So you can get that look where you've got blue in the sky by reversing some channels. You can get silvery blue leaves. Custom white balance, once you've done a conversion, is a lot of fun. Do a custom white balance on with a 720 nanometer converter camera. Do it on bitumen, a road surface, green grass, healthy green grass, or blue sky, and you'll yield a slightly different. You might get that Seavertone look, but it's just quite a bit weird when you've got something that reflects a lot of IR, like the chlorophyll in healthy plants that go really white and bright. So it's another. So go ahead.
Oh no, I was about to start getting specific about what I would like to achieve. You said that sometimes what you guys do when someone sends their camera in, they check the camera and they also talk to the customer about whether or not what they want to do makes sense. Before I do that, the book that graphic was from, David Leparati says the book is Color Doesn't Exist, A Practical Guide to Infrared Photography by Rob Shea.
Oh, yeah.
And Jeff says Rob Shea is a guru. Love
Yes.
hard eyes face. David also says his Fuji XE2 was converted to 590 nanometers by Imaging by Design. So that's cool.
Yeah, 590 is a cool, fun frequency to work with a lot of different false colors, and you can get quite a number of effects.
Yeah.
I have seen a product on the market. I see it less now, but they're kind of drop-in filters that are on a frame that you sit within the bayonet mount, and they just suspend above the natural filter of the camera. How do they work? What is the difference there?
So, like any filter, be it on the front or a clip-in, that they require a camera to have a spectral conversion done to it, normally a full spectrum. So if you're going to get clip-in filters and they're infrared or some other frequency that you're interested in, then you need to get the camera first converted. And it's really good idea to notify the conversion company that you're going to use clip-in filters, because remember what I said about the diversion of light through a filter? Well, here's your infrared filter, for example, we've put in front of the sensor. Here we go, try and get this stage. Sensor, infrared, sits on top. Then you're introducing another filter between the lens, which is normally sitting here. What that means is that you're changing the focus plane again by the thickness of this filter. They're quite thin and delicate. You've got to be careful with them, but when we do that conversion, we take into consideration you're using a clip-in, but they're a good option. They're just a little bit pricey, considering you can get a screw-on filter for the front. Now, you can buy stacks of infrared filters and other spectrum conversion filters, unless you want a really sharp cutoff. In other words, it reaches its peak frequency in a very short range, like 5 nanometers or 2 nanometers. That's a sharp cutoff, so the curve would be straight up to 720, then along. You don't need to pay a lot of money for a filter, an infrared filter. You know, you can spend $180 on a very expensive one, but you can also spend one for $40 and get equally as good results.
Right. Yep.
That's what basically those filters, Greg. That's what I'm thinking of doing. I'm thinking of converting. This probably goes against what most people do. Most people seem to convert an older camera or something like that to have a play around with. I'm thinking of converting one of my newest cameras. I've got 2 new Canon. I've got an R5 Mark II and an R6 Mark III. So current model cameras, and I would like to convert them to one of them to full spectrum, but still be able to use it as a second/backup camera for professional work by installing one of the clip-in. Essentially, it replaces from what I understand, the bandpass filter that you've removed. It kind of replaces that with a clip-in filter when you require it. Is that a bad idea? Will that work? Is it going to degrade the image quality massively?
No. So, providing the conversion's done well by whoever's doing the conversion,
it would be you guys.
Cheers. There's heaps of companies out there, and we're not the only ones that are doing conversions, and I encourage people to have a look around. I know we offer a really good product, and we've been doing it for a long time, but by all means, shop around. So your conversion, full spectrum, great option. It gives you the flexibility to bring the camera back to normal color. The bandpass filter that you put inside the camera will never give you the same color that you got out of the camera in the first place. Okay. It will be close, but there will be things that are just slightly different, and you'll notice that in the color tones. You can achieve almost spot on or negligible difference by doing a custom white balance with your camera. Or you can do, if shooting raw, do it in post, and you'll know the shift. It might have a bit more magenta in it or something like that, and you'll know exactly what to shift out of it. So it's a great option. You never get exactly the same out of it, but we're talking about, really critical divisions of change that most of the time wouldn't be any concern.
Okay. What about the Canon R series as it is? Is it a reasonable option to? So one of the things that's been brought to my attention is that many lenses from various manufacturers can have a light inside them that can affect infrared images. What's that all about?
Yeah, so that's a good point, which leads us into the inside of the cameras and how they work as far as detectors are concerned. So when we change the spectrum response of a camera, it then becomes sensitive to invisible light that we cannot see with our own eyes, which is really cool when you think about it. You got an infrared camera and you're taking a picture of something that you just can't see. It's just madness. So I remember doing a job for a client in Sydney, and they were an art director of a play. And what they did is they had, it seemed really bizarre, but they had a play live on stage, and all the actors in the play had night vision goggles on. They could see themselves. And we had to build cameras to film the audience watching a play they couldn't see from actors that were wearing night vision goggles that could see the audience.
Wow.
Yeah, I that was my reaction too.
What? Yeah, what?
I love the creative time. So yeah, we recorded the audience watching a play they couldn't see. And the actors had night vision goggles, and they were on stage doing their work.
That's crazy.
That is crazy.
So there's only part of the stuff that we get, but the infrared sensor inside the camera is built into the shutter units here. So inside this shutter unit, to detect the blades open and closed, can I open and close this one? Yeah. So here we go. So to detect that movement, there's an infrared filter inside infrared sensor, and it's called a photo interrupter. It's basically a beam of light between 2 points, and when it's broken, this beam of light, it detects that it's broken. A bit like a doorway buzzer when you walk in. Same thing inside this. Now, when we take this thing out, it becomes sensitive infrared. You can see the bloody thing, and that's a big problem, especially if you're doing Astro work. And some cameras have got very strong infrared photo interrupters in them, and they sit at about 650 nanometers. Some of them, some of the Sonys, shocking for Astro conversions, because you do a 3-minute exposure and you get this pink bleed across your image. Furthermore, the lenses that you're talking about, some of the lens manufacturers, particularly Sigma, Tamron, Tokina, they have photo interrupters inside the lens that detect the centralization of the optical unit for the vibration reduction, and they detect the start point of focus. Everything has to have a home position when you have a lens. Like, okay, here's our infinity spot, and you move from here to here. It has to know where the infinity is. So they'll use a photo interrupter. It's a great device because there's no mechanical parts. Unlike a touch switch, which will eventually fail, these don't have failure points, and they'll last forever. However, when you've got an infrared converted camera, you can see that. What we try to do, and we're working on publishing this on our website when it finally is finished, is we photograph the lenses with a converted full spectrum camera to see which ones have these anomalies in it, which have the photo interrupters that bleed through. Some of them you can see, some you cannot. Most lenses, new lens, have them in there. Any new autofocus lens will have some sort of photo interrupter in it, or they'll have a magnetic reader, which then doesn't emit light. That's even better. But most of them have some sensor in there, but some of them don't just bleed through and show up. Some of them hit the glass inside the lens, and that's what you can see when you take a picture. So in your case, yes, some lenses that you put on that will show up. Mm-hmm. If you're doing an Astro conversion, and it's typically they stop at about 680 nanometers and cut off, most of the photo interrupters, the sensors, sit at 800 nanometers inside the lens or inside the shutter unit. So you don't see it when you do an Astro conversion in most cases. So mirrorless cameras work really well because they're live view focus. So they're excellent for that.
Is that
just
what
to be clear? Sorry, Greg.
I just for point of clarity, is that what some people are meaning when they refer to when you're doing infrared shots? Some lenses create a hotspot. Is that what people are referring to?
Not quite. No. So this is what we're talking about is a bleed that comes through as normally as a magenta cast. It comes out as a spot somewhere on the lens. The hot spot is a different phenomena, and that's because the infrared light that's bouncing around inside the lens is hitting the edge of the optics, and it's creating a anomaly, or the coating itself is creating an anomaly where you have an intense point inside the middle of the lens, and it's accentuated by the angle of the light that comes into the front of the lens and the aperture that you're on. Most lenses have some sort of hot spot, but it's barely noticeable. Some lenses are shocking, and the 4/3 formats show up a lot. So the Fujis and Olympus and things like that, the micro 4/3, that it's just to do with the image build and size, and where how the light bounces around inside the optics. Right. It will create a hot spot. There's no one particular. There's a few companies that have some lists that do cause it, but it's really hard to reproduce. It won't do it all the time. If you put your hand or a hood in front of the lens to reduce the scattered light coming in, you can knock it down a lot. Polarizing filters can work, but they need to be special polarizing filters that work with infrared, because the normal polarizing filter or ND filter doesn't work with IR. You put it on, it does nothing. You see straight through it.
Wow. Really?
Yeah, and just on that point, you've seen, particularly in Australia, where our government, that particularly in Victoria, that need more money than they've actually got, there's cameras out there, I won't get political, but there's cameras out there that are used to detect whether you're on the phone or not in your car, and whether you're not concentrating. They use infrared for those cameras because they see through Polaroid glasses, and they'll see through tinted windows really well. So you can see where your eyes are looking in the photograph, and they'll use a tele lens on it. They're quite precise. That's the reason why. Back to your question about the lens. You just have to try it, unfortunately. I'm happy to tell you, if you've got a lens, we can look at it and let you know.
Trial and error. Well, I mean, that's why I want to do the plan that I have, which is convert one of probably the R6 Mark III, the cheaper of the two cameras, because I've got a range of lenses, and from what I've read about Canon's R series lenses, some of them will definitely work. Others might have some hot spots or have the potential for a little bit of that light, but I don't think it's bad with Canon from what I remember, research I did. I can't remember. I just figure being the more lenses that I've got to experiment with, whereas if I go with a convert a secondhand older DSLR or something, you spend a fair bit of money on the conversion. Yeah. But then I need to buy a range of lenses to work to experiment with, So it's kind of, I looked at it and I was like, it actually doesn't make sense for me to convert a cheaper camera, because I might end up spending as much money on this kind of secondary kit that I only use for infrared. That was my thoughts.
Yeah, no, we see that a lot. Sometimes we get clients that'll bring in a secondhand camera and we'll advise them this model is end of life. In other words, parts unavailable for it. Now, typically it's 7 years. The camera manufacturers keep parts for cameras that have been out for longer when they're popular and they're still out there in circulation or still being sold, or professional units are longer than that. But it's hard to pick up parts, of a camera that's 10 years old. And that's really important. If you're going to spend $600 on a full frame conversion, I think it's $625 it is, including GST. Then you want to make sure that camera is going to keep it going for a while and you can keep servicing it. So new cameras conversions have been quite popular, and when we do a camera conversion, we don't void the warranty. So if we've done a camera conversion, we have agreements with the manufacturers that if you've got a warranty issue with the camera and you take it and it's been converted by us, providing what we've done hasn't caused the issue, if it has, we'll honour that and repair it at no charge to you. But if they go to the manufacturer and the main circuit board's got a fault because the main circuit board's got a fault, it's got nothing to do with the infrared conversion, that's fine. that's
Yeah.
still,
that's
yeah.
That's good peace of mind. Yeah.
Yeah. A couple of quick questions for you. I'm conscious of time, so we're just about to hit the 2-hour mark. On average, how many conversions would you do, say, in a month or a year at Imaging by Design?
They go in stages. Like at the moment, they're coming through pretty hard because it's getting closer to winter and there's a lot of Astro stuff going through. So it's probably, I don't know, maybe 1 or 2 a day at the moment.
Oh, wow.
Yeah.
That's quite a lot.
Awesome.
Yeah. And then we might be at a range of them as well. So there's on the conversion, depends on the type of conversion we're doing to what is disabled and not functioning after the conversion. The focus is always accurate. On a mirrorless camera, it's accurate. It doesn't matter what lens you put on it. On a DSLR, the focus changes according to the focal range because the autofocus sensor is working invisible, but now the camera is seeing an extended range of light, and the light focuses at a different point in infrared compared to visible. Now, if you remember, some of those lenses used to have a little extra red dot next to the center focusing mark. If you get a prime lens, if you've got one out there, and have a look at it, you'll see there's a small off-center red line next to this the actual focusing center line, and it's normally just before infinity that your lens will focus when you're using infrared, and that's the infrared focusing point rather than the main. Yeah, so it was put in lenses many years ago. It's dropped off a lot of the new ones now, but it was still on some of those ones. So focusing has changed. We correct it and we balance it according to a range of lenses that the customer might be using, and it might be wide angle if they're doing some landscape infrared stuff. So it'll be calibrated between your sort of like 14 to 50 mil. If you put a 100 mil lens on there, then the focus, you'll need to do a manual correction or a live view shot to get the focus spot on. Mirrorless cameras, like I said, are great. They always will be sharp, doesn't matter what lens focal range you put on there. The autofocus sensor cleaning mode is disabled in all of your IR converted cameras. Is that the filter that we put on doesn't have that item adhered to the front of it or stuck on it, and removing it from the original filter can be problematic and dangerous. The Astro conversions, we maintain them in about 80% of the cameras, so we let the customer know. These are the ultrasonic cleans that have this cable on them. They're high frequency cleaning mode. It's not the one that uses the shake of the actual sensor. If you've got one of those, the sensor cleaning mode will always be active and working.
Right.
When we do the conversion, if it's disabled, we normally turn that feature off in the menu anyway.
Yeah.
So it doesn't matter if you've got it on, but it's still disabled.
Yeah. So it's camera dependent as to whether you retain sensor cleaning. That was just a question David Leparati had. And there's another question here as well from Pete Mellows. He says, are there any brands you won't convert? I've yet to find anyone who does Pentax.
Well, we've got a KX. No, what is it? It's I'm just trying to think about the model that's upstairs at the moment. I saw a Pentax there in the workshop. So Pentax, Olympus, Fuji's, not a problem. The only ones that we don't convert are the sensors that are glued, the bandpass filters that are glued to the front of sensors. For example, a Sony, what is it? It's not an A series, no. It's an RX10 Mark 5 or 6, I think it is. We've got a list of ones that we can't convert because we just don't pull the glass off. They're glued on. Yeah, they're the ones. Phones, no, don't do much of those anymore. Unless people come up with, sort of, which we've done a project, we had like 100 phones we converted. They're difficult to get into.
Wow.
Yeah, bit of fun.
What other questions pop through here? Jeff wants to know, is the process the same for IR conversion and HA conversion?
Yes, it is. The one thing that we do different with the HL for conversions is that the critical when we take the sensor out, underneath here you can see these points, these holes here. There's a couple here and there's one down here. They're the mounting points. I do it behind the black. They're critical that when the sensor's screwed down, that it's completely parallel to the bayonet mount. On a H alpha, they're unforgiving, so we pay a lot of attention to making sure the edge to edge is sharp. You don't want those stars out on there. Now, with the Astro work, we do some full spectrum stuff, and that works very well because you put a filter on the front, and that works great. But there's not many. There's no one that I'm aware of, unless they're doing focus stacking, that are shooting with a full spectrum converted camera for Astro work, because you get star bloat. You get such a difference between your ultraviolet frequency and your near infrared frequency. They're so far in the focusing points that you can't get anything sharp unless you take multiple pictures at different focusing points and then stack them together after that. So most of the Astro is either a full spectrum and clients are putting their own filters on, or they're actually a H alpha, and the mirrorless cameras work really well. We've had, I think one of the best series cameras to convert, or we've been converting recently, they've been the Z series in the Nikons. So the Z6 Mark III and the Z7s, if you want the high resolution, they produce a really good result.
Right. Maybe I'll have to switch back to Nikon. No. All right. One more quick question, maybe not a quick question, or maybe it's not something that you're that familiar with, but in terms of clip-in filters, do you have any recommendations, or is it really just a matter of see what's available for your model in different people making those clip-ins? Or do you sell any clip-in filters?
We don't. We were working with Calibration Vision on some clip-in filters, and they've stopped that range, which I didn't mind them. They were quite nice. So we don't have anything currently. There are a number of filters, clip-in filters out there, and they all work very well. The stability of holding them in is the critical part. Sometimes it's good to put a little bit of extra, so like some double-sided tape or just a bit of tape on the edges just to make sure they don't fall out. And use tweezers, plastic tweezers, to get them in and out. They work well, so you don't scratch things. But it's about finding the filter that has the frequencies that the brand that has a frequency of filters that you want. So that's probably the more critical thing, more important one.
Yeah, I think Kalari is the one that I sort of saw. They had a range that seemed to suit, and they've got the hot cut mirror, they call it, which I think is essentially allows me to use it as a normal camera again. Which was important. Right. But they do have listed here, like, would you like a magnetic mounting plate? So I assume that's what you mean by something that holds them in place a little bit better than just sort of sitting them in there.
Exactly. Right. So, if you can opt for that, it's a good idea. Okay. Yeah. And they're quite a thin filter, so they don't have much impact on the focus.
Okay. Yeah. And it's I'm excited. I'm gonna be so if I wanna send it in, I just call you guys and book it in and then post it down or something.
With all our repairs that come in, you don't need to make a booking unless you've got a specific time slot which you want to achieve. So, for example, with our pro photographers that use their cameras all the time, they'll book a time slot and send in the equipment, and we'll get it done in that, rather than have it left with us and it sits in a queue for a bit. So we do have those facilities. It's normally reserved for pro photographers. With our Astro work, check on the turnaround if you want, but you just send it in with your note and details of who it's from and what you want, and we'll contact you, send you an SMS that it's here. It's as simple as that. And payments done over the phone. We've got your camera, it's worth more than the repair, so you don't need to pay up front.
Well played. I like that.
Yep, that's fair. It's like,
if you want to see your camera again.
Yeah. Also, the price just doubled.
Just
I'm excited. I'm really excited to experiment with infrared. I think it's going to be really fun. Landscape has never been something that's been my thing, but the the idea of going out and not knowing what I'll be able to create again, and experimenting and seeing what scenes look like with different frequencies and different channel swaps and custom white balances and stuff. It's really intriguing. So
Yeah,
there's so many cool filters around now, and you can just pick them up at a relatively good price. They're a lot of fun. You get some really creative effects that you cannot do in post. You know, you've got light that you're dealing with that you can't see and it's not always visible. But then there's also the forensic side of things, that we do a lot of that too. So we work with Attorney General Department, FSL, Defence, the Vic Police, and they do a lot of, especially in crime scenes, they do a lot of UV stuff. You know, the only way to tell if there's tattoos on a cremated body, which is a bit macabre, is with an infrared camera. You can see the tattoos from a body that's completely black and burnt.
Wow.
Yeah, because it's at density. It operates on density of material and reflectivity and absorption of the light. Yeah.
Gosh, there's so
That's
much to
fascinating.
it. You guys must have had to acquire so much information over the years on just various industry uses and things like that. It's crazy.
Yeah, we're getting into thermal a lot at the moment, because we've got an agency for Thermtech, and they bring in a lot of decent thermal cameras. So that's another level again, you know, with thermal camera on paint surfaces and stuff. Good fun.
Have you had to play with any drone stuff?
Heaps
for agriculture or various things like that.
Yeah, NDVI indexing of plant health. We've built heaps of those. I think we've done hundreds of drones conversions for converted cameras, and you know, even things like just getting an absolute position out of the drone when you capture, so you can use a thing called a PPK, which gives you real-time positioning in the sky. And when you take a photograph and another photograph and another photograph, and you know where you are, you can form a 3D model and you can start to measure heights. So you fly a field of new planted pine trees, and then you fly it again in 12 months' time. You can see the growth rate of the pine trees, and you can determine which areas need more attention than others. So,
Wow,
you know, there's lots of cool stuff you can do.
Yeah. It's interesting because it's not a side of you know, the photography industry that we often hear about or see or even know existed. You know, I knew that there were fancy drones for different things. We've seen on, you know, television where drones are being used to track agriculture, like the yield of each tree for a fruit tree and things like that.
Yeah.
It's just growing and growing and growing, isn't it?
Yeah, well, yeah, it is. It's really cool, and it's so much more than just imaging.
Yeah,
it's information. We do solar panel systems for imaging the state and health of solar panels, particularly in Victoria alone. There's about 1,000 panels a week come off roofs that are decommissioned for various reasons. And we're building a system with a company at the moment, so they can image those panels when they come off the roof and decide whether it's recycle or reuse. Now, the recycle program that Victoria have is absolute rubbish, because they just crush them for aggregate and they put them in concrete. In the other states, they recycle the glass or the aluminium, but for some reason we've got this. The reuse part of it is that, you know, here's a panel that's 95% of its output, and would you buy that for 70% less than the normal price, and that it gets put back on a roof somewhere. So it's a really decent list. But there's special cameras that we build to take those photos.
Yeah.
To check them.
Wow.
Oh gosh,
So cool.
It's so fascinating too.
Could go on all day about this stuff.
We might. I do want to ask you a couple of more personal questions about your creative journey. So, do you get out and shoot? And if so, what do you shoot with?
Yeah. Okay. So, I love photography. And like I said before, I did my diploma in photography at Photo Studies College. So that was a good fun 4 years of just everything from lighting to chemistry. And it's a great culture, and it's a really nice way of meeting people and sharing. My partner and I, and Julie, she's absolutely amazing. She's the only person that gets me out of this place. Otherwise, I'm here 24/7. And we hike. And when we hike, we take photos, and I love taking. I'm fairly personal, so I don't publish these things. The social media profiles is not there, but I've got gigabytes of images and some. I've been told by some really, well-respected photographers, which we have the honour of associating with, that they're pretty decent photos. So we just did recently the Cape to Cape walk in WA, and that's like I think it's 137k and about 20 odd k, 25k a day. Got some really amazing coastal shots there. It's a beautiful neck of the woods. So yeah, and what I shoot with, I love my Traveller, and it's a Fuji. I've started with the XT1. Now I'm working through these XT3, 4, and 5 range. It's just a nice travel camera that's convenient. It's APS-C, not full frame. The beauty is that where we work, what camera do I shoot with? Any camera I like. There's heaps of,
and we've had perk.
Yeah, it is. It's really cool.
Yeah. So with that in mind, do you want to ask that question, Justin?
Well, I want to change the question because I just thought of something. So you're essentially you are essentially like a car guy that owns one of the coolest like hot rod modification places in Australia. Have you ever built yourself just the most wild, like you ever put a V8 in a Camry kind of thing? Like, do you ever take the sensor out of a GFX and wang it in a point and shoot or something like that?
Absolutely. We're doing that sort of stuff all the time, and it's the time is the issue with me, is because we're running a service center, and last night I was midnight because I was designing a high precision total imaging system for surveyors, and we've got a trade show coming up next at the end of the month in Sydney so we've got to get this electronics built for it. So I was working on that. So when I'm not doing that sort of stuff and designing projects, and we'll build cameras from scratch up, we'll buy the sensors, the naked raw sensor, and build the electronics to go around the camera, because you can do so much better than what we've got. What we've got out there is awesome, and what you get out of a camera is fantastic. Considering what people don't see is what we see, is what do you get out of a raw image from a sensor? What you're seeing is raw, is not the actual true image out of the sensor. There's, out of a 24 megapixel sensor, there's at least 3,000 dead pixels and probably about 10 lines that are active, and they're just turned off with pixel mapping. There's tap balancing to make it all look even and nice. You get rid of the vignetting on the lenses. The vignetting is horrible out of a lens when you put it on a normal sensor. So what you actually get as a raw image is the presented raw image. What you get, what we see out of the camera, is pretty ugly, and you wouldn't use it. So I love to work with sensors and build optics, like dual lenses, shift registers, things like that. We put a 127 megapixel aerial camera in the sky a while ago, and that was pretty phenomenal, with 2 lenses next to each other, so we could get the 127 2 sensors over that range to get a really nice oblique image of high detail aerial imaging. So when I get a chance, I'll put liquid through a camera to get it down to minus 10 degrees. The challenge is not to have condensation on it, so you got to do it over a period of time. So fans in it. The challenge with fans is vibration. So there's all sorts of really tricky things that we love to challenge ourselves with.
That's awesome. Well, I guess, maybe I should ask that. So the question we normally ask a lot of photographers that come on the show, I forget sometimes, is if there was a zombie apocalypse and you had to grab one camera and one lens to run off into the hills with and document the zombie apocalypse where you try not to get eaten, what camera and lens would you grab if you could only grab one?
Pick on my grandmother. That's a tough one, isn't it? There's so many ripper units out there. I would get the Kodak 14N.
Hang on. I got to Google this. The Kodak 14N. Let's bring this thing up. Okay. Hang on. What is this was that the Nikon one?
Yeah, it's a
Bring
hybrid
it up.
camera. So it's a Kodak sensor on a standard SLR camera with some electronics. Clunky. There it is. DSC 14N.
Is that it?
Yeah, that's it.
Whoop. Go back. Why this thing? Oh,
And I'd probably grab.
Oh, wow.
I'd probably grab a Nikon, maybe a Nocta 1.2. And it's just a really nice TTL sensor. They were mounted in an ultraviolet glue, which would separate, and they had problems with the things shifting. But it just gave a beautiful render, and it has got a fantastic tonal range.
So,
14
how many
megapixels.
14 megapixel, really?
Yeah,
That's why the 14N. Okay.
Yeah.
Where's it?
Yeah.
It hasn't got much up.
Full frame.
Yeah, go through the whole. Yeah, right. So this would be the camera of choice. Look at that.
Yeah. Got a clunky thing.
Well, Jeff has said that that'd be heavy enough to whack the zombies
Like
with
a
too.
zombie, 100%. Yeah,
exactly.
It's a multi-tool.
Brutal. Yeah, exactly. Yeah, it's defense.
That's a
mechanism.
beast.
It is a beast. Look at the big Kodak Professional. The
Because
grips
they
look
were
pretty
just
interesting.
innovative. You know, I've got some sensors from these guys when they were making. They've got Kodak have got heaps of patents on sensors. They invented the organic LED, which are used in cameras today. So they were very innovative, just badly managed, and that's why the company went down.
Yeah.
Really good technology in these things, and they were out there before anybody else was.
How big is it? Yeah, look at it. It's a
That's-
super
it's-
interesting design.
Yeah.
We have a collection of cameras here, which we call it the ugly box, and there's about 35 different cameras that are very unusual in their build and make. And hopefully soon we'll be into a bigger premises, and we're going to have them on display.
Yeah, that'd be great.
Oh,
Little museum. That'd be
Yeah,
awesome.
little museum. But it's just not your normal museum where you got all these fancy, one-off rare Leicas and other things like that. These are just the things that you would, weird. And you've got to credit to the designers and engineers that got it over the line in the company in the first place. Convince management, the bean counters, to say, give me $2 million to design this thing. I will sell 4 of them.
And I'm sure you do not have the time for this, but Bruce said this earlier in the comments, and I want to read it out. He said, "I don't know about anyone else, but I want Wayne to start a YouTube channel and show us all the things, techniques, knowledge on why and how and stuff." And I if only, because imagine that, all the weird cameras and things. If you ever want someone to just come around there and point a video camera at all the cool shit that you guys are doing, just let me know. I'll be more than happy to.
All right. Yeah. Look, you're in. I think I might strap a camera to my chest, and because the day-to-day stuff we see is really free. We had a camera, like I say about doing speed cameras. We were being servicing robot speed cameras for decades here. We had one camera come in, and it was full of ants, these tiny little ants. I'm not sure what the species were, but they had specifically eaten the red insulation off all of the wires in there that were red. That's it. I only ate the red insulation. So there's all these wires with no insulation, just bare copper. So what the hell?
Wow.
Oh, no.
Yeah.
That's so funny.
Tasty.
Bad stuff.
Maybe they were miniature bomb technicians, those little ants, and they were like, cut the red wire.
Always cut the red.
We got to defuse this thing.
Yeah.
Oh, that's amazing.
Wow, that's crazy. Yeah, so I just bought. Oh, it's not in here. I just bought a Insta360 Go Ultra. It's called. There's a few other brands doing it. It sits on a pendant magnet mount on there. If you were ever going to do something, that's the easiest thing that I've ever used to be able to just film what you're doing with your hands in that moment without having to strap a GoPro to you or something like that. You can either clip it to a hat, or you can just clip it to the magnet on your chest and just hit record and then just go back to your work and worry about it later.
That's probably neat, because otherwise, we've got a lot of gimbals and other things like that, but they're sort of big chunky things.
Yeah, and you're always too busy to think about doing.
And you're not hands free that way.
Yeah.
Yeah,
with gimbals,
yeah.
you know.
Yeah, true.
Yeah.
Yep.
Crazy.
Yep.
Sweet.
Anything else before we let you get back to your busy day?
Oh, look, if you've started me, I mean, there's heaps of things. That
We can
Like,
go
you
on.
know, die-cast aluminium covers, what's built in our main circuit boards, things like that.
Yeah, wow.
Backup
Well,
batteries.
okay. Well, very quickly, let's talk about very quickly Leica, because you guys you deal with a lot of Leica stuff. You said you've been trained by Leica in Germany
Yes.
multiple times. And you said it's the metallurgy that make them. There's one of the things that sets them apart. Is there anything else in terms? You know, I've got this Q3. It's the only Leica that I could afford. Maybe one day I'll be able to change lenses on it on a different one, but it is quite amazing. The image quality is astounding in this camera.
So, Justin, why did you buy the Leica then?
I went to the Leica store in Melbourne. I had lusted after a Q series since the Q first come out,
But there's a reason for that. What's the reason for lusting after those Leicas?
A couple of things. One was a little bit the technical specs of, I can't believe there's a full frame sensor in this very tiny camera with an amazing lens on it. There was that, but then there was this like mythology of the amazing images that you can create with this tool that's kind of surrounded Leica forever. And when you're a newer photographer like I was when this come out, and it's this $10,000 camera that, you know, all your dreams will be realized if you could only purchase one. It was kind of that. And then that festered for however long it was, 10 or 12 years or something, until I could finally actually afford the Q3 when it came out. That's why.
Yeah.
And then and then when I put my hands on it, it felt amazing to hold when I finally actually picked one up and shot with it.
Yeah. So I think you've nailed it in that respect. You know, we're talking about the ergonomics and the usability of the camera, or the ergonomics. You know, they've got a sexy feel, and they're solid, and they're built from solid materials. You know, there's a 45-minute video that Leica released on the building. I think it was the T2 or T series camera, where it's machined out of a solid piece of aluminium, and it's just the time lapse of this machining, and there's your body casting. No other camera manufacturer do that. They just pour it into a mold, die cast aluminium. So it's the ergonomics, the feel of it, but ultimately it's the image quality, and that comes from the optics. So Leica make beautiful optics. They always have, and their M series stuff is made in Germany, and German engineering is excellent. They're very particular. They're very staid in their ways. And I remember going there and looking at the workshop, and I was thinking that I'd step back in time in some areas, but they do it. What they do very well. And there's a level of respect in Germany that I noticed for technical ability, for technicians that have that understanding and capability. Whereas in other countries, it seems to be I don't want to, disrespect anybody, but it seems the salesperson gets as much attention or respect as what the engineer is that comes up with the items that the salesperson has just sold. For example, an IT company. So they've got a different sort of respect and level there, and the pay reflects that. They've got people that just work specifically on designing a rangefinder. Dr. Duck, I met him there, and he designed the M240 rangefinder, and that's all he designed. That was specifically his task. So they've got, and in the Japanese camera manufacturers, you'll have teams of people that do it, and it's CAD design and build. Now, don't say it's not CAD design in Leica, but the ergonomics are feel. There's people that understand the look, the feel, and the positioning of buttons and things like that. Not to say they don't have their quirks. I mean, the M rangefinder is, very idiosyncratic. It's a hard thing to use, but the optics are great, and that's what sets them apart. The Japanese optics are excellent. The Leica's ultimately Japanese the Q series are Japanese optics anyway. They're licensed too. So Panasonic.
Okay.
So
Really?
Panasonic are the ones who are responsible for a lot of their boards and other. They teamed up with them years ago doing all of the compact cameras.
Yeah, I remember that, and they were kind of almost rebadged-ish. People would be like, well,
but they were different, and we have both. We have both the Panasonic and the Leica in, and you look at the two images, they're different, but it's the same sensor and same optics. What's the difference? It's what Leica wanted to look like, and that's what you're buying.
Yeah,
you're buying look, not just the red dot.
Yeah.
Okay. The curly question then. So the Leica look often gets described when it comes to the lenses as what are the words that they use often, but like 3D pop gets talked about with the lenses. Is that a real thing, or is that just people trying to justify their $20,000 that they spent on a 50mm prime?
Yeah, I think it's what would you call it? It's just a chick word. It's just a click word. It's a catchphrase. At the end of the day, it's the ability to render your tonal range and resolve, and it's your resolution. And if you've got both of those, you can have a lens that looks sort of soft but sharp. So what does that mean? What do people say when they say it looks soft but sharp? Okay, yeah, you've got detail, but it's got a nice smooth tone.
Yeah.
And the M series lenses do that. The S series lenses did that. The T series lenses, the TL series stuff, they're a bit more poppy. And the Q does that. So that's what you get, and you can get that from a full frame sensor, and especially if you've got big pixels, you can get the tonal range because you can get the detail. You've got a light well, pixel light well, they're this big instead of something that's this big. It's tiny. You can grab more pixels floating around, and that's what you want. They're the important things, the photons.
It's cool to hear you say that. I think there was a lot of talk about bigger pixels for a long time as the megapixel race was happening, as we were seeing more and more megapixels. But then after a while, I see now the chatter more seems to be that people say there's no benefit to a lower resolution sensor because you can just shoot with a higher resolution sensor and then use noise reduction in post-production or something like that. Do you think there is, say, a benefit to a really great 24 megapixel sensor on full frame over, say, a 50 or 60 megapixel sensor on full frame?
Absolutely, without a doubt. There's no doubt about it. And it doesn't matter what anybody says. You can't distract from the dynamic range. The dynamic range is the ability to render detail in shadow and in highlight. And we build imaging systems for photographing roads, and there's nothing more dynamic than the sun falling on a road surface, be it concrete or bitumen, and we're trying to get detail to the millimeter cracks, and you want to see them, and we're looking for large dynamic range, high dynamic range sensors, and they're measured in decibels when dB when we're searching for sensors in technical specifications. The simple fact is that the smaller the light well, the less photons you're going to get, so the less dynamic range. So you won't have as much information in the highlights, and it's the highlights that get sacrificed the most. You can normally pull shadow information out, but once your highlights blow out, they're gone. They're gone forever. Your whites, you just don't have it. And you see so many pictures because people are used to looking at things on a monitor. So you're sharing your images on a monitor. Now the dynamic range of a monitor is crap compared to a printed photograph. So you're actually happy to accept an image that you can't see. Where's the white detail? It's like there's lots of tonal range in this reflection on my head. Believe me, it just looks like a white spot. So that's what we're accepting it because that's how it's been, I guess, shared now.
Yep. The final
On a
output
screen?
is
Yeah.
already being squished, so we accept that throughout the whole chain.
Yeah.
Yeah.
So it is important. It is there, and that's what you look for. Look, when you get a sensor, and so that's your pixel size on a CMOS sensor, take that off, and that's all your electronics around the sensor, right? The actual pixel, to get the charge out of the sensor and off to the circuitry. So all of that is lost in space. Then you've got this pixel here, then you've got your next one here. But again, you've got this gap. So the two of them aren't close to each other. So you've got information in between, in the middle, that's not resolving. So you don't know what's in between. The camera has to interpolate that. So it could be red or green, or changes between those colors in that pixel, and that's to do with the chromatic aberration. That's what you get. That's to do with the Nyquist frequency. There are all sorts of design techniques. Then the manufacturers come up with something like a backlit sensor. What the hell is a backlit sensor? They've got lighting from the back. No, what they do is they go, oh, we've got this electronics here and here. The electronics are that thick, so the light has to travel down into this little tiny hole inside the pixel, past all these electronics. It's like trying to get sunlight in the middle of a city, and you've got all these tall buildings. You only get the sunlight when it's right above. Right? So what do? You go, we'll drill a hole in from the back of it, flip it upside down where there's no buildings and just holes. So the light gets in. It doesn't matter if the light's coming on this angle or that angle. So it's taking that person from the middle of the city into a country field, and you look around and you've got light coming in everywhere. It's just doing this, whereas in the city, you're only getting that. That's a backlit sensor. So you get more light. Simple as that.
Wow.
Because
I had no idea that's what they were.
Yeah, I had no idea. That's amazing.
In my mind, I'd never even really thought about it, but in my mind, it conjured up that thought of, you said, of basically a sensor with a light behind it. I was like, I don't know. I guess that's what it is. I have no idea.
Yeah. It's, electronics take up space. It's as simple as that. It's components. They got to stack them.
So it's essentially flipped. The design is flipped. It's backwards to the traditional design.
Yeah.
Right.
Great idea. Somebody thought, we'll drill some holes in here. This will be cool. Get the light in. Look,
flip it over.
much
Let
there.
it in the back. Open the back door.
Yeah.
Wow.
Oh, wow. That's amazing. That is
amazing. Man, there's so much. There's stuff that I don't know. About how a camera works. There's so many things that I just do not have any knowledge on.
That sensor there that I showed you, that with the coatings bugger, that's an M9 sensor, and that's the coating that can deteriorate on the sensors. So we've just got a technique that we're about to commercialize now, where we use a UV laser to blast this filter off and then replace it with a new one. So we're bringing them back to life.
Really?
That's very cool.
Yeah.
Wow.
Yeah.
I know I can't remember if the M9, what technology the M9 was. I know the M8 is desired by some photographers for the particular.
Yeah, it's a TTL type sensor, so it's not a CMOS.
Yeah.
Yeah, so that's the idea. Well, it's a sort of a hybrid. So, and the reason that I say about that is CMOS sensors have the electronics that I said about here. If you can picture these fingers as actual components on the side here, tiny little ones, be it. And this is the space where you get your charge come in here. Whereas a TTL sensor, it's the whole thing, and they have these special things called a shift register down the side, and they're very thin and small. And they take the charge off here. They use the next pixel to take the charge off. It's quite a neat technique.
Yeah, wow.
Yeah.
But so the reason for the change, why they went away from TTL, what were the downsides of that?
Okay, so TTL, you can't turn the pixels on and off quickly because you have to have a shutter. You can't have electronics. You can't do video. So video requires the pixels to turn on and off 30 times a second. So 30 frames per second, 24 frames a second. So it has to go electronic shutter. So it captures everything, all of the light, takes it off the chip, and gets ready for the next round of photons to hit it. It takes it off and takes it off like that directly, instantly. And it's got to get rid of it, and it has to do that 24 times a second. 24 frames a second. It's taking that off every time and dumping it to the processor, which then turns it into digital media that we can recognize, images. Now, on a TTL sensor, what it relies on this pixel and this pixel. So the charge goes from here to here. And then it goes to the next one and the next one and the next one. Then it gets off to the edge of the sensor and it comes down through a thing called a shift register. So you got to get the charge off before you can start a new one. You can't do that in that short time, in that short nanosecond.
So even if they wanted to just make a purely like redesign that style of lens for a modern photographic only camera, no video, would it still be too slow to say do something like a 10 frame per second burst or something like that? Or
could you get it off on a shift register fast enough serial? You'd get that. You'd get 10 frames a second burst, but you've got to, it's a mechanical shutter. So you've got to make sure you can get a shutter that will do 10 frames a second. So at 1,000, sort of the fastest blade shutter speed, focal plane shutter, you can get is 8,000ths of a second. Whereas your video, you can do, much higher, 10,000ths of a second. Video. Yeah.
Oh, we got a final question, which I actually forgot to ask about, which is also something I wanted to know. Is it true that a converted camera, so full spectrum or IR or whatever, cannot be reverted back?
Oh, no, not at all. We do that often. We get clients to bring in and say, right, I've had enough of this. I want a different frequency, or I want to go back to what it was, original filter. So where possible, we ask the clients if it's okay to keep the filters, or we just, if they're not interested in, which most clients don't, because what are you going to do with this piece of glass apart from holding it up for a podcast? Yeah, we'll hang on to these, because if somebody wants it converted, we can pop that in. So then you're just paying for the labor, not the part. Because a piece of glass in infrared, quality piece of glass without bubbles, scratches, nicks, or defects in it is very expensive.
Yeah.
Okay.
Makes sense.
So it would be possible if I converted my camera, it would be possible to get it converted back if I wanted to resell it and no one wanted to buy the converted camera. I could then actually convert it back. You
could do that, but you'd have more chance selling it converted than a plain camera because they're more sought after.
I would imagine so. Yeah.
Yeah.
I would imagine so.
Yep.
Amazing.
Yeah. Very cool. I mean, we should probably let you do some work. Fearless Hyena Design says, I tried cleaning my Nikon sensor. I wasn't sure. Do you peel the potato first or just dust it off? Was that a thing of, like, going around for a while about how to clean your sensor using potato or something? I can't remember something about that.
I love. We did like a little YouTube clip messing about, and we had a whole lens, and we took it off because it did cause a little bit of issues. But here's the best way to clean your optics in your lens. And I had this long zoom lens, and I just popped it in the sink, washed it with a bit of dishwashing fluid, wash it around, let that dry for an hour, and you'll be right. So,
oh no! Nice. Was the problem? Some people thought that was real.
There was some questions that I go, no, this has gone too far now. This is almost considered feasible. So we had to be careful. So some literal things can be taken that way, but potatoes are great on windscreen. I must say, I've done that. I've tried it. You get a potato, slice it in half, rub it over your windscreen, and the water beads off. When you run your windscreen wipers over there, it leaves a little streaky mark, so it's not that pleasant. But no, not on a sensor, absolutely not. There's nothing. Okay. All right, I'll give you a tip on the fluids that we use for sensor cleaning. And there's quite a few of them. Shellite, right? Shellite is what's used in a zip. I guess it's a chemical that is petroleum without oil. Basically, it's used in Zippo lighters. You can buy it at service stations. It's very clean. It leaves virtually no residue. It's excellent for removing stickers, double-sided tape. It doesn't damage plastic. It's great for cleaning lenses. It will remove oily marks and grease. So a tissue on a lens from the sensor wiping out in circular motions lightly after you've blown it, that is, because you don't want to have, again, swarf on there and scratch it, sand. So out. So the tip is a little bit of condensation. That gives you your moisture fluid that removes your water-based contaminants. The shellite removes the oil-based contaminants. You'll have a crystal clean filter with shellite. You can use shellite for cleaning sensors. However, it's not as easy as what other chemicals are because the evaporation time is slower than what something like acetone is. Now, I'm saying this reluctantly because acetone will absolutely wreck plastic really quickly. It's unforgiving. You put a tiny bit on your cover and you wipe it off and you've got plastic damage instantly. So if you're going in with acetone on your tip and you go too close to the edge, you can destroy your shutter. So I don't recommend it, but we use it because it evaporates very quickly. It removes oil and water-based contaminants. And it doesn't leave streaks at all. And it's also got static properties that are more indicative of negative ions. So it doesn't build up static very easily. Then there's isopropylene alcohol is the other one. Now there is a mix that you can do and play with the three of them to get a ratio. So that's the type of cleaning fluids that we use in the workshop all the time. We use acetone heaps because screws that are inside cameras have got Loctite on them, and we need to use acetone to soften them to take them out. Otherwise, you shear the head off. Yep. So, and special screwdriver tips that are very, very hard.
Yeah,
there's great cleaning fluids out there that work equally as well as these that are already pre-mixed.
I was going to say, I assume if you buy like one of the, I know places sell cleaning kits and stuff like that. I assume it'll be some sort of blend or one of those things or whatever. And they've just already sorted it out and put it in a bottle to go with the
ammonia, some detergent, things like that. Yeah. So there's plenty of options in there, and ether as well as another good one. It's also, if you've got a still, it's good fun to use as well. The thing with the cleaning fluids that I mentioned, they're all flammable. So you can't travel. They're dangerous things to have. So that's
don't smoke while you're cleaning your sensor.
No.
Yeah.
Well, also you've got, people don't understand this, but the cameras have got capacitors in them for the flash, and they store a lot of electricity. So there's over 360 volts inside a camera. Unless you discharge that, it's quite exciting when you realise that.
Quite exciting.
Sounds exciting.
Yeah, absolutely.
Here we go. Quick question. Would you use shellite for the front element of a lens? Thinking what effect would be on the coatings?
Yeah, shellite's a great safe product to use on a lens, and it won't destroy the coating. Don't have a lot of it. Apply it always to the tissue or the cleaning cloth, and only a small amount, a couple of drops. Anything that you can possibly saturate, like a cotton bud, might penetrate around the edge of the lens and under it. So all of a sudden you look at your lens and you've got this fluid creeping underneath the element, then that's a bit of an issue. But yeah, it's quite safe to use. So it's an excellent cleaning product, and it's great for removing your sticky labels and things like that. If you're one of those people that put tape over your cameras to protect them, when you remove the tape, the shellite will get rid of the stickiness without destroying the paints or anything. It's safe on plastic and metal glass.
Yeah, that's good to know. Really good to know.
Yep.
Look at this, Greg. Alyssa says we're welcome at Imaging by Design anytime. Just go down.
Thank you.
We'll just go take some photos and stuff. Just annoy them. Like, what's this? What's that? What's that do?
Yeah.
Alyssa, Alyssa and Julie on the front desk, they're great value. So if you're going to come in, you've got to do two things. Bribery always works really well, so chocolates are great. Alcohol
Donuts?
for Julie. Yeah, donuts.
Okay.
I like donuts. And a dirty joke.
Okay.
Okay.
I'll write these down.
Yeah.
Profiling. Great. But look, I think that might be a great place to tie a bow in today's episode of the Camera Life podcast. Wayne, more than a font of information, maybe a fountain of information. It's incredible to hear some of these things that we just take for granted as camera owners, as photographers, and and you've certainly cleared up a few misconceptions for us too. So we appreciate your time, and on behalf of everyone here, and obviously our audience, we really want to thank you for the last. It's almost been 3 hours, I think.
It's crazy. Thank you so much.
You're very welcome, and it's an absolute pleasure to share, a bit of what my life is like at Imaging by Design, and to share it with the chaps at Camera Life. So thank you for the opportunity.
Thank you.
Thank you. But on that note, I think we'll roll the outro music. And Justin, you want to say goodbye to some peeps?
I do. Bruce Moyle says, Firehouse of info. Amazing. Thank you.
Nice.
Firehouse. Fire hose? Firehouse. I don't know. David Leparati says, thanks, Justin and Greg, especially Wayne, for a great, very interesting and informative chat. And Pete Mallow says, thanks for the fantastic distraction from work.
Get back to work.
Bruce says fire hose. Yeah, sorry, I should have picked up on that. Thanks so much. Jeff says it's been a fantastic session. Bruce is doing 3 things at once. Who else was here? Paul Henderson says, what a really interesting conversation and somewhat scary. So many things can go wrong. It makes you think about how we look after the camera, lens, cap, filters, and clean them. Thanks, Wayne. What else? There's tons of people here. Philip Johnson says, thanks, Justin and Greg and Wayne. Very informative. It was awesome. Looks like Jeff had a few things converted by Imaging by Design. He says service was 11 out of 10.
Sweet.
Amazing.
I want an amplifier that goes to 11. That'd be neat.
Yeah, exactly. All right, we'll catch you guys in the next one.
Be safe, everyone.